Okay, welcome guys. It's July 19th, first hour, 8:30. I'd like everyone to welcome Cameron Carper. Uh we're gonna cover a different kind of database as promised. NoSQL MongoDB, which is just a next evolution beyond the good old RDBMS that we've been using for 40 years or so. Cameron, the way this rolls, I'll pause during the breaks and whatnot. I need to do the advanced sharing options and let you screen share. But other than that, you're in charge. I'm just going to do everything I can to bite my lip and listen, take notes. We generally break at right around a quarter after the hour for 15 so that folks can check email, social media, get up, stretch your legs. So take a 15-minute break, teach for 45, 15 until you think you've um, covered everything you want to cover today, and then we'll adjourn for the day. So guys, I have no assignments coming up where you'll set up MongoDB or do any Mongo query language queries or anything like that. This is just for your awareness and career breadth. So if you introduce yourself and take it away, Cam.
Sure. And if you want assignments to give out, we can take some from my class. You're free to use them.
All right, we'll talk.
Yes, my name is Cameron Carper. I've been a developer or at sometimes architect for about 15 years here in Central Arkansas. I'm currently a principal architect at Acoustic. And in about late 2015, early 2016, we started moving away from our monolithic Java applications that had an Oracle backend and into more microservices. Typically, we build our services with Node.js and use MongoDB as our metadata store because they pair extremely well together. I may inadvertently slip a little bit of Node.js in here, but for the most part, we're planning to focus on Mongo itself. If we just have extra time at the end, then I'm sure I've got a few very small examples of how if you wanted to connect a Node script to Mongo and run a query against it, it's something like 20 lines of code, so it's no big deal. Where I'm going to start is I am going to be running MongoDB locally. And so I'm going to just dump a ton of links into the Zoom chat that you are welcome to follow along if you want. I've already have everything downloaded and installed, and I have published a companion GitHub for this class that I will drop in the chat first. It does not actually have the links in it, although I will add them because they're a part of my normal stack class. I also teach a mean stack class, which is Mongo, Express.js, AngularJS, and Node.js at the Arkansas Coding Academy. So really, we've just sliced out a small portion of that, particularly the Mongo section, and that's what we're going to talk about today. So I will make a note to add a README to this GitHub that includes the links to download Mongo and MongoDB tools and a ton of other things, but I am going to give you a quick run through of the things you're going to be seeing, just so we've got an early heads up. And like I said, I will also drop some links as we look at them into the chat if you want to follow along. So clearly, if we're going to be working with MongoDB, we need MongoDB. Personally, I prefer to run it locally. I prefer to run all things locally when I'm doing development and testing, just because it rules out the internet and access issues and anything else. If there's a problem, it's on my machine, so it's simpler to figure out what the problem is. And then once I've got my general proof of concept working, then I move on to a more realistic environment like a hosted Mongo database or potentially a cloud database like we will most likely have time to talk about briefly as well. So your standard place is mongodb.com. Your community edition is the one that is free for everyone to use, and the community server is the MongoDB server. You have a list of available options here. It's up to you how you want to install it. I personally prefer to do the zip method because I get a binary compressed file, I unzip it to a folder, I know it exists there. And one bit of setup I'm going to show you is I create a new folder to store my data. Clearly, we have to store our data somewhere. It doesn't all just exist in memory. So we have to give it a place on our hard drive to store that. And since I unzip this package to a particular location. I create my data directory in that same location. I know that if I somehow massively mess up my Mongo install, I just erase that folder, unzip a new one, and I have a clean fresh install and everything's good to go. So that's my personal preference, but feel free to do whatever you would like. It is, of course, available for Windows, Linux, multiple precompiled for Linux, also I think Source, and Mac OS as well. So all of your major operating systems runs on all of them. In addition to this one, which you already have downloaded, so we'll move on, there is the MongoDB tools, and specifically the MongoDB database tools. These used to be packaged with the server itself. They split that out, I don't know, maybe 2 years ago. And it is a much smaller file or group of files than the database server itself is. The primary reason you might want these is for ease of importing and exporting data into your database. We don't have to go write a custom loader in whatever language to get stuff out of Kaggle or GitHub and get it loaded into Mongo. We can simply have a JSON file on our file system and say Mongo import that into this database in this collection. The one that I probably would, I told you I'd give you a link to these as well. The one that I probably would recommend downloading right now if you're going to follow along is Mongo Compass. It is an IDE for working with MongoDB. There are several of them out there. Compass is functional and it's really good at some things, but it's really bad at other things. So I find myself jumping between a few. If I'm working on aggregation pipelines, I'm probably in Compass because it's really easy to work with aggregation pipelines and they're pretty complicated. If I'm actually researching and manipulating data, Compass makes it very difficult to modify existing data in your database because it's more of a observational tool, not a manipulation tool. So I typically switch to another one. A really good one is Studio 3T. It has, however, in the past year or so gone commercial. I think it requires a subscription. The old version Robo 3T does not, if you can still find it around. And more recently, I've started checking out one called NoSQL Booster. I'm very new to it. I've only used it for a week or two. It seems a pretty good mix of the three I've listed, I think. So that is also out there. This is more background a bit. I teach my classes from Windows because the majority of my students use Windows. Personally, I'm not a Windows guy. I am 100% on Linux in my personal life, and in my commercial working life, they won't let me have a Linux machine, but they will give me Mac, and it's close enough that it's effectively the same. That said, since I am teaching from Windows, the command prompt that comes with Windows is pretty terrible. And if you're working with code, you're probably working with Git already. So if you install Git SCM for Windows, it will include a application named Git Bash, which is what you're looking at here. And it's a terminal emulator that gives me a more powerful command prompt that is more similar to Linux and Mac. And so it's a lot easier for me to work with. On that same note of me not being a Windows person, if you see me doing something stupid in Windows, it's probably because I just don't know how to use it very well. With the exception of these classes I've been teaching, I probably haven't used Windows in about 20 years. So it is quite foreign to me, but trying to stick with the same technologies that our students are going to be using. I will pop that link in as well if you don't already have it. One more thing that I will be using that because we write our Mongo queries in effectively JSON. It's a little bit special, but we can treat it as JSON. Our queries get rather large rather quick. So it is often quite difficult to write any type of remotely complex query in, say, Compass or one of the other IDEs, just because if we're going to format it nicely, it's turning into 30, 50, 200, 300 lines long. So some type of editor that can handle JSON natively is very, very helpful. Since in my other class, we do a lot of JavaScript, we use VS Code as our main editor. It's free, it's open source, it works pretty well. So I won't bother to throw that link in because most of you probably already know about it. You may already have it, and it's not necessarily required, just whatever your favorite editor is for working with JSON. So that is the lead up on all of the software that you may want to grab and start downloading if you're going to follow along. Specifically, Mongo Compass is going to be your most important. However, if you're going to run Compass locally, you need the database, so you'll need MongoDB as well. I will show you how to start up MongoDB locally. It's very simple, as well as how to load some data into it. One note, I always keep a little notepad here of things that I need to be 100% sure I do not forget. If you're running on a Mac with the new M1 chip, MongoDB will throw an error when you try to start it originally, unless you've already installed the Rosetta translation layer. So if you haven't done that, or if you try to start MongoDB when we get to that section, and it gives you an error, something about potentially the wrong file format or the wrong architecture, simply running software update -- install -Rosetta, potentially with sudo, I forget, that should install the Rosetta translation layer, and then it should just work after that. So minor little gotcha if you're on a newer Mac. Now, with pretty much all the intro covered, we're going to jump into our first section, which is actually not Mongo, it is JSON, because since we're going to write our Mongo queries in JSON, we need to know what JSON is and how it works in order to be able to write queries. So we'll talk about JSON first, then we will do a generic intro to Mongo, which will be running it locally, loading data into it, and then running basic queries. We
Hey,
will
Cameron.
then, yes, sir.
Hey, I just want to make sure, I might not have put this in the right perspective, but it could be that folks don't even realize what NoSQL stands for, or kind of
Okay.
the motivation behind MongoDB and that family of technology versus your good old tried and true SQL relational database. So I didn't know if you were going to cover that
In that
in your
case,
material, or because I
yes,
just want
we
to make sure
do cover.
everybody's got a good solid handle on the real basics of this technology and why it exists.
Yes, I do have a generic overview of how it compares to relational databases.
Cool.
It might make sense. Let's hit that lesson first, and then let's go back to talk about JSON so we know why we're talking about Mongo in the first place. So let me rearrange one thing to make sure I've got the correct libraries. And let's talk about the generics of MongoDB, and then we may just actually go through this entire lesson that includes setting it up. And then when we get to the point of needing to execute queries, we'll talk about JSON first. So my slides are mostly important points and talking points to keep me on topic, to make sure that I don't go entirely off the rails. So there's not a ton of information in them, but it's a way for us to have things, make sure that we hit everything that's important and don't miss anything. MongoDB is, of course, as the name suggests, a database. It is, however, you'll notice we've talked about relational and how it's not a relational database. It is a document-based, or sometimes it's called a document store. It is distributed. That's very common as well for relational databases, where instead of having a single server that is your database server, and if it goes away, you're just out of luck, it's very common to have, say, 3 servers that replicate to each other. If one goes away, you've still got 2 working, your application still can continue to function. Mongo is effectively, or it is exactly the same in that regard. It is scalable, both horizontally and vertically. So you can have larger machines that have more power to scale it vertically, or you can add more machines horizontally in order to share a workload across. Say we have 3 servers and that's not enough for our uses, we can add 2 more, make it 5, and do that horizontal scaling. Small mention here of both on-prem and in the cloud. Obviously, things these days are moving more to the cloud, have been for many years now. You can run your own Mongo databases in your own data centers if you want. You can also, there are multiple cloud providers, including Mongo themselves provides a application named Atlas, which is a completely cloud hosted and hands-off implementation where you just say, give me a MongoDB instance, and it gives you the connection string, you set up your credentials, and you're good to go. Like I said, we probably will have time to do a setup with Mongo Atlas in the end. Comparison to a relational database. Again, the very important thing is that Mongo and document stores in general are not relational databases. If you try to treat them as a relational database, you're going to have a bad time. Instead of storing, when we think about relational databases, we think about tables that define columns, and there are records that each record has all of those columns. And we may have multiple tables that represent a small normalized type of data. And the normalization piece of that being that it's a very limited and strict, well-defined type of data. And we store those different types of entities in different tables, and we join in between them, hence the relations between our tables. In Mongo and document stores in general, this isn't specific to Mongo. Our records, what we would call a record in a relational database, is a document, and it's stored and represented as JSON documents. It's slightly more complicated than that, and it's actually stored in on the file system as BSON, which is a binary JSON format for speed and compression. But we can safely just treat all of this as JSON. And we're in a relational table. Each of our records would have fields or columns. In JSON, we have properties. The relational tables in MongoDB or a document store, we have collections. So to rehash that real fast, we would have a collection that contains documents, and those documents contain properties. Since this is JSON, which again, we'll talk more about here shortly, that means that we can nest objects and arrays. If you've ever tried to deal with a field in a relational database where you need to store effectively a list of items, it's not very pleasant. We get that natively and easily with MongoDB and most document stores, because if we're just storing JSON, JSON can natively nest effectively infinitely, up to technical limitations. So we'll see examples of how nice that is here shortly, but just keep that in mind. It is a fundamental paradigm shift on how you treat your database compared to relational. Similarly, we were talking about a relational database. When we define our table and we define our columns, we have to specify all of the columns that are going to be in our table, and we have to specify types for all of those columns. If that changes in the future, we have to go back and modify that. MongoDB is what's called schemaless by default, in that it has flexible document formats. We do not necessarily need to specify our quote unquote fields or columns or the properties in our documents. We also don't necessarily have to define their types. And we can also have two documents that potentially have exactly the same property name, but have different values or different types stored in them. That is not necessarily a great idea, but it is possible if we stick to a 100% schemaless format. And I talked about this shortly when I was talking about dealing with arrays or nested objects in a relational database, which is very painful. Nested objects and arrays are allowed by default in MongoDB. So we literally just put them in our data, hand it off to Mongo, it accepts them, it stores them, and we're good to go. So those are the things that are different than a relational database. And it was primarily terminology and some of the basic structure of how it works. But it being a database, there are several similarities between Mongo and a relational database management system. First, which you can probably assume, is we have our basic CRUD. We can create or insert new records. We can read or query those records or documents in Mongo's case. We can update them and we can delete them. So nothing crazy there. It's the The general interaction of how we deal with the database is exactly the same, just the way we actually make that happen is different. The data types comparatively are the same at a very simple level in that we can store strings, we can store numbers, we can store booleans, and so on. There are some more complex types that we will talk about towards the end. I don't see them used that often, but if we're specifically looking at this from a data science point of view, they may have more relevance to you. It's typically things like more specific types of numbers instead of just saying, this is a number and I'll take whatever you parse out for me. We can do like int32s, int64s, and I forget the full list because I don't use them that often, but I think I have them listed later in this presentation. So there are more precise types that we can assign, but if you're using this as what is very commonly used for as a metadata store, that's typically not that important because any potential typing enforcement is usually done at your API layer, but we can also do it in Mongo if we want. As with the relational databases, they have indexes, and if you've worked with them, you know you need to be careful and judicious about how you use your indexes because they should align to how you're querying and using your data. The exact same thing is true with Mongo. It supports databases, it supports indexes or indices. For some reason, Mongo and I think databases in general have decided that they are indexes, not indices, but I will typically use the term indexes because that is the command we use to create one in Mongo. We have a entire lesson on indexes. So brief intro just to say that similar to relational databases, we can do indexes there. We can do them in Mongo as well. And they are, just like with the relational, they are very important, especially when you start getting your data at scale and choosing the correct way, the correct fields to index and how to index them to make sure that your queries against it are as fast as possible. You've probably assumed that MongoDB is ACID compliant because it's hard to have a database that anyone takes seriously that isn't. The only reason I put this point in is because it's been many years, but in the past it wasn't. I think it was around version 2.5 to 3, somewhere in there. It may have even been earlier than that. The earlier versions were not ACID compliant. And after that point, which again has been many years ago, it is ACID compliant. I do occasionally still see things floating around the internet of, oh, Mongo's trash because it's not ACID compliant. That was true at one time, at least the not ACID compliant part of things. That is no longer true. Another thing that you might see on putting Mongo down is the quote, it doesn't support joins. Mongo, as best as you can, you should not be doing joins because that's a relational mindset and MongoDB is not a relational database. That said, it actually does to a degree as of, again, time flies, 4 years ago, 5 years ago. They're called lookups in Mongo. We'll see examples of that, but it has the same general purpose of how you do joins in relational databases where you have two tables, in our case, two collections, and you need to say, I want all of the records in that table that match a key on the other table. So we will get into that. It's one of those things, again, just want to make this very, very clear. You can do it. You should try to avoid doing it if at all possible, because it is going to be very slow. And here are the more specialized types I was talking about. These are the types that are supported by BSON. I told you that we're going to interact with our database in JSON. That's how we'll route our queries. And when we look at our data and inspect it, we can mostly treat it as JSON. Under the hood, what's actually written to the file system in the storage for our database is truly BSON, which is our binary JSON format. So the general types that we will work with, the very obvious and easy ones, because if you've ever worked with JavaScript, string, date, objects and arrays, and Booleans. In JavaScript, we typically just say number, just give me a number, and don't worry so much about what type that number is. unless it's for a very specific purpose. I generally do the same with Mongo because I'm interacting with it from JavaScript. So I take my type in JavaScript, I hand it to Mongo, it stores it as needed. But as I mentioned a few minutes ago, you do have the option of choosing more specific JSON types, such as doubles, the 32, 64-bit ints, and longs and decimals. Again, that's one you'll have to think through your data and what you're using your data for to determine if you actually need one of those. I can't think of any examples of things I've needed where I've been working with extremely large numbers where I had to go past my standard number type, which I believe goes well above the trillions. I just taught that lesson 2 weeks ago. A very, very large number. I've never needed to go past that, and so it's worked for me, but depending on your applications, you might. So just keep that in mind. And let's see where we're at as far as, okay, so coming up next is our install. So let's go ahead and do that because we're going to come back to talk about JSON before we actually start writing queries, because we want to know what JSON is and how it works before we start writing those queries. So let's go through a very quick run of how to install Mongo locally and then get it running. And that will probably actually take us up right to our break, maybe a little bit before. So if you've already downloaded all the stuff we talked about earlier, most importantly, the MongoDB community server and potentially MongoDB tools if you're also going to import and export data as part of this lesson, then I am hoping that I still have my downloader around. See, I've got Compass. All right, so here we go. I'm just looking at my download folder and I'm looking at the download of MongoDB that I did 2 months ago-ish. So in order for this to be more realistic, since I've already got it downloaded, but I already have one instance that's already configured and working, I'm going to create a new one. So I'm just going to create a new folder for this class. I'll go into, I like to throw all my temporary stuff in work. And I'll create an ACDS folder. And copy my Mongo instance in here. I get this behavior is going, or this general flow is going to be exactly the same for every operating system. If you downloaded the zip, extract it. And it's not exactly small, so it does take a second. And now I'm going to use git bash just because it's easier to work with. You can make this work on the command prompt. So at this point, I have my extracted MongoDB community server. So I will cd to that directory. Nothing much in the root besides the information, documentation, licensing, that kind of thing. Bin is clearly what we're looking for because we're wanting the binaries. And you can see that there is not much here. I'm actually glad I did this because this reminds me, if you are running on Windows and you have not installed the Visual C redistributable x64, if you're on a 64-bit machine package, it is packaged with MongoDB. It's very common to be required on Windows machines, so you may have already installed it. But if you try to start Mongo and it just immediately returns if you're running from the command line, if it just immediately returns a blank prompt, it's probably because you haven't installed that VC redist. And since I know it's installed, I'm going to execute MongoD. So we have 3 main binaries here. We have mongo.exe, which is a command line Mongo client, MongoD, which is the Mongo daemon or the deep database. So that's what we're looking for really here. And then MongoS, which I believe is Mongo shell. I very rarely use it. So I'm going to make this a bit larger and I'm going to execute MongoD and it is going to fail. So it failed pretty fast. And it outputs logs in JSON format because pretty much everything in Mongo is JSON. And so this is probably hard to read on the screen share, but I'm looking for this error. Non-existent path, data directory, C data DB not found, create the missing directory or specify another path. The reason I wanted to point this out is because I personally don't like putting my database in my root folder. If you're running this in Linux or Mac, I think it will try and put it in your /root. So, or literally your root, not /root where your root user's home folder is. I don't like polluting my file path with that. So as I mentioned earlier, I prefer to create a directory to hold my data. So I typically throw it one directory up just to be separated from my binaries and call it data. So if you're not familiar with the command line, all I've done is create a folder that is one folder up and I've named it data. So now I have a folder in work ACDS Mongo Win32 /data, which can be seen here. So this is the folder I've just created. And then the only thing I'm going to change about my Mongo invocation to actually make it work and to make it so it writes all of my data into this folder. Again, so if I mess everything up, I can delete that folder and I'm back to 100% fresh start. Is execute MongoDB again and pass it one parameter named dbPath and give it the path to the folder where I want it to write that data. If you don't want to do this, you can write it to a temp folder or anywhere else, but this just keeps it a little bit cleaner for me. And because I'm in Git Bash, I should have used a period / to say in my current folder execute MongoDB, except for I mistyped it. It's MongoD, not MongoDB. And so now again we've got a large dump of output, but you can see it's still hanging on. It's running in daemon mode, so it's going to sit here and continue run and wait for connections until I come back here and do a Control-C or a Control-D and actually tell it to kill this process. So at this point, MongoDB is running, and when I'm doing development, I usually start it up when I start and leave it for days or weeks on end because I know I'm going to be using it again. It would be a good idea to shut it down with a Control-C before you do a reboot just to be safe, but it would probably be fun. All right, so that gets us to MongoDB is currently running, but how do we know it's running? I told you that we also had the command line Mongo client in this directory. It's not easy to work with because it's command line, but it is a very simple way to do a test of if Mongo is actually working. So I'm going to navigate back to that directory. And one of the really convenient things about running this locally is if I execute mongo.exe, so my Mongo command line client, if I don't have to give it any parameters, and it's just going to default and assume that I'm wanting to run and connect to a Mongo database that's hosted on my local machine. So it will default to local machine and to the specific default port, which is 27017. We'll see that again later. But if I'm just needing to do a quick test to make sure Mongo is working, I can execute my Mongo shell. You can see that it started up and got a session ID. It's connected to MongoDB server version 5.08. And you can also see that logs are continuing to spool out in the background in our MongoDB instance. And I may just want to run one command that said to ask if I'm connected and if things are working, like show databases, which if I'm not mistaken is exactly the same command you use in a relational database. And it does in fact have 3 databases that it came with by default: admin, config, local. At this point, I know my database is up and working. Now I can go use a better, more easy to use client like Compass and actually start querying it. So for the most part now, I won't use the Mongo shell again, except for I will look at Mongo import to import some data so we have something to work with. But other than that, we're going to switch to using Compass or potentially NoSQL Booster, mostly Compass.
So this is kind of like just getting the database up and running
Right. Yeah. At this
on
point,
your
this
machine,
is
kind of like Python sits there and runs in a, in a little window that you rarely have to mess with after you
exactly.
start Jupyter Notebook or whatever. So
Yeah, this is getting it up and going. So now that we can actually work with it, and the most of our lessons, most of the points in our lesson also include examples, or I will provide examples. And so I needed to have a Mongo database running that I can execute those examples against. So I'm not just showing you text on a screen and saying, trust me, it works. You will actually have to check and prove that I may know what I'm doing.
sure. I just, for the folks that are not database administrators, you're getting to kind of see the magic of the man behind the curtain here. There's a database running when we use Workbench to work with MariaDB and do our normal SQL queries. There's a database running on that server that we connect to that somebody has to do all of this kind of setup and configuring and whatnot, just to get the engine running as well. So,
Right.
uh,
And of course, this is a very simplistic approach. That this is not realistic to what would actually be done by a MongoDB. Of course, we would have multiple servers, multiple instances.
sure.
We would currently, it has no authentication or authorization on it. I think that's actually my next slide is security warning. Uh, Heads up, anyone who can connect. All right, well, so it's better than it used to be. In the past, several years back, if you started a Mongo instance like I've just done, then there is no authentication or authorization, and anyone that could connect to your computer could connect and do whatever they wanted to that Mongo instance. They did change it. Again, it's been several years ago, but this old problem still floats around, so I want to address it. It does now only accept connections from your local host. So even if we're on the same network and I start up this development server, you can't connect to it. So there is no authentication and authorization. This is only for local development purposes, but it is very similar to how you would roughly get started on setting up a real production database. So I think so we just did our install and our security warning. It's what we just talked about. And I think a few quick commands, I will actually go execute these back on the Mongo shell or the Mongo client. We'll run a couple of commands that'll get us a basic database set up, and then we will use that database when we load data and start querying against it later. And this is going to take maybe 2 to 3 minutes, and so that'll bring us right up to 9:15. So I did lie when I told you we weren't going to use the Mongo CLI again, but just briefly. And actually, I'm glad we talked about this first because this is an interesting bit. I mentioned that our server, our MongoDB server, is currently running in development mode. That means a few things. First of all, it means that there is no authentication or authorization. I connected, I did not log in, and I can do anything. Second, it is configured to automatically create databases and collections whenever we use them. And that is probably going to be a very foreign concept to anyone who's used to relational databases, in the fact that I can say, this is the same command for a relational database. I can say use ACDS, except for I have to be running Mongo. Once I'm in Mongo, I can say use ACDS, and it has switched to a database named ACDS. I never created that. I just said, hey, I want to use this database. And the potentially even more odd thing is if I say show databases, like we did earlier, you'll note that there is no database for ACDS yet. How can that be since we just switched to a database named ACDS? The way this works is that, again, in development mode, it will create databases and collections for you when you write data to them. So while I am using a database named ACDS and Mongo is perfectly happy for me to do that in memory, it doesn't truly exist on the file system yet. So that won't happen until I actually create a collection or insert into a collection. And then once that data needs to be written to the file system, then it will truly be created, and then it will show up in this list. So just for the purposes of, we're going to use this again in the future, we're going to use this database, so I want to make sure it's created. You can also explicitly create them. And I should note that again, being in development mode, this is not what you would expect in a production environment. It can be locked down to only allow databases to be created by admin and not created automatically. Collections only be created by admin or explicitly or by user with certain roles. It has all of your standard database authentication and authorization levels for controlling access. It's just running in dev mode. It knows you're just wanting to get up and running as quickly as possible, so it just automatically does it for you. So I'm going to execute one simple command, one simple Mongo query, which is, we're going to talk about this a lot more later, so don't get too hung up on this, but we're going to invoke a command to insert a single record into a collection named test collection. And I'm just going to give it some JSON where I have a field name test and a value that's a Boolean true. And I mentioned that it's difficult to work on the command line. It wasn't looking quite right, and I hit backspace, and apparently I didn't do it quite right. So let's try this again. Okay, yeah, so when I had started manipulating my command, apparently something didn't display correctly because I just copied and pasted it again and it was fine. So last thing to show before we take our break, now that I've actually written a file, one, we should see that our database exists now. Yeah, we now see an ACDS database, and we also should see that a collection named test collection was automatically created, which is that right there. So that's a great place for a break. Don, you said 9:15, right?
It is. I just wanted to point out, guys, what that test equals true. That's the same as a key value pair in a Python dictionary that we covered, I don't know, 3 weeks ago. Same basic concept. You have an identifier and what it's identifying, key value pair. And I'm sure Cameron's going into that in much greater detail as we move forward. But yeah, let's pause recording. And any questions before we hit break? Questions or comments? All right, guys. I will pause recording. Let's return at cell phone time, 9:30.
All right, so where we left off, we got a MongoDB server running locally on our machine so that we could start playing with it. And as I mentioned, I can actually, instead of just showing you commands and queries you can run, I can show them to you, then we can run them and make sure they actually work the way that I tell you they do. So there is one extra step that I want to do before we talk about JSON, and that is with the MongoDB tools, because I want to load some data into our database so that I have records to actually query against. And by records, I mean documents if I was going to use the proper terminology. So the way we can do that is with, again, the Mongo tools, and specifically I'm going to use Mongo import. I do have it downloaded. I have not extracted it yet, so I'm going to open my folders back up and copy it from my downloads folder to this folder I'm working in and extract it. And then switch over to that directory. So there are several tools that are available in this package. Usually the only one, since I'm not a DBA, I'm just doing this for, I need to load a few thousand records to test with or something like that. Typically the only ones I actually use are Mongo import and Mongo export. They do exactly what you would expect. One imports data into Mongo, one exports data out of Mongo. And since at this point, I'm just wanting to get data into Mongo, I'll be using Mongo import, of course. To make things easier on me, I'm going to take my data file and just drop it into this directory so I don't have to do any crazy pathing things. I mentioned that there is a GitHub that I put in the Zoom chat. It has a couple of data files included in it. And if I can find where I've put that, or potentially I haven't cloned it to this machine yet. All right, let's do that real fast. So now you'll get the full experience on a Git clone as well. So go grab our URL from this GitHub. And I'm just gonna put it in generally the same area, do a Git clone. Again, I'm not terribly used to working in Windows, so I can't remember to do Shift Insert for pasting on this terminal, so I end up right clicking, but it'll get us where we need to go. And now I'm going to go back to my tools folder. And I said that I was going to take the data file from the GitHub and copy it to my folder so that I can easily import it. Obviously, you can work your file paths however you want. This is just, it simplifies it a little bit for me, especially since these are rather small files. They're about 500K each. So I'm going to grab both of these and drop them in the folder that has my Mongo tools in it. And then we're going to do a Mongo import. There are tons and tons of parameters this thing can accept. I'm going to go as basic as I possibly can, which is I'm going to tell it that I want it to import these into a collection named people. This is randomly generated data from mockaroo.com. So heads up, the data we're working with is completely fabricated and 100% random or 100% generated. So not real people. Just like with our Mongo shell, when I just executed Mongo, it automatically assumed, since I didn't tell it otherwise, it was going to connect to my local Mongo instance. So localhost port 27017. Mongo import will do exactly the same thing. So I don't even really have to tell it where to connect to. But I do want to tell it that I want to use a database named ACDS. I've already created this. We saw it was created automatically for us when I started inserting a single test record into a collection. If I had not done that already, this would have created it as well. And of course, I need to tell it what file I need to import, which is acds data-1.json. And I have messed up one thing. Instead of database, I believe this should be DB. Great. So the first error where I mistakenly used database instead of DB as the parameter, I did not intend for that error to occur. The error we see on our screen now, I did intend to occur. Often when we're dealing with JSON data, and we'll be getting into the JSON lesson very shortly, with JSON data, if we're moving a large list of data around, it's typically encased in an array, which is, we can think of it as a list. And so it's very common to have JSON data on the file system that is basically an array that has a bunch of objects or documents inside of it. In fact, it's more common from my experiences to see it that way than any other way. However, by default, Mongo import doesn't expect to receive an array. So if you're dealing with data that is formatted that way, and we are, you have to add one more parameter to your import, which is --JSON array. Take note that the A is capitalized and it's case sensitive. And this tells Mongo import, this is the file we're looking for, and heads up, it is a JSON array, so deal with that appropriately. So with that extra parameter, now we should have data actually imported into the database. And you can see we got 750 documents imported successfully from that one. And I just split this into 2 files for ease of generation, so I'll just load the second one exactly the same way. So we've loaded 2 files of 750 documents each, so we should have, what, 1,500 records or documents in our database now. And I think that, let's double check, but I think this is the perfect time to switch to JSON. Yes, because yes.
I just want to ask a stupid question.
Mhm.
And we'll probably get there, but maybe, so 750 documents, conventionally, generically, your computer user thinks of a document as a file that is a Wikipedia page or the Constitution of the United States or whatever. It's a document is a single entity, but you're using that term, and MongoDB uses that term differently. We just opened one file with 750 documents in it. And tell me again what a document is to Mongo.
Yeah, the easiest way to relate it to a relational database is what we would call a record, or a row in a relational database is a document in Mongo.
Huh.
And
okay.
So yeah, in relational tables, we have records or rows, and in Mongo collections, we have documents. So it's a collection of documents, and each document is a self-contained independent JSON document that will have properties and potentially sub-properties and so on, almost always sub-properties. It may be helpful to help lead us directly into the JSON discussion to take a look at this file that I've imported.
Cool.
It's not a small file, so it's going to be a little bit hard to read, but it will give us a generic idea, and then we can look at simpler ones. So this is effectively one JSON object per line, and all of it's wrapped in an array. And again, we'll talk about those terms here shortly. But you can see we should have 750 lines. Yes, we have 750 lines. So effectively, every line is a JSON object, and each JSON object is imported and inserted into Mongo as a JSON document. So in that situation, we could actually consider an object and a document to be synonymous. If we go too far with that comparison, it won't hold water for long, but at the level we're looking at it right now, it works. So let's do a quick slide type overview of what JSON is and what to expect from it, and then we will look at quite a few examples. And after we've done that, we will jump back to Mongo and actually start writing queries with JSON against the JSON data that we've just imported. JSON stands for JavaScript Object Notation. Obviously, based on the name, it is used very commonly with JavaScript. It's really, at its core purpose, it's a way to take things we have in memory, so JavaScript objects and arrays and strings, numbers, all the type of data structures we have in JavaScript, and turn them into a more easily readable human format, as well as a safer format, because we don't want to write binary memory data to a file for someone to go work with. We want to deserialize it, or excuse me, serialize it into a easy and safe to transport format that can then be given to anyone or posted on the internet easily. And then if someone wants to use that same data set, they can deserialize it, which means taking it from text form and moving it back into memory, and then they can work with it like normal. Covered a little bit of this in my brief intro about why do we deal with JSON, why do we have it? To make data safe for transfer, as I said, if we're transferring data over the internet, especially in things like API calls or remote service calls. Doing it in binary comes with a lot of challenges because if we have a binary string of characters that represents a specific technical aspect of whatever protocol we're using, it could cause us to break that protocol. But if we're just transferring plain text is safe to transfer. Nothing expects it to be control characters that govern the session we're currently in or doing anything special. It's just, here's a block of text that I would like to give to you over the internet. So super simple and safe to transfer. It does the situation I just described where we can take binary data in memory and serialize it into plain text and put it in a file. So those two files that are in the GitHub that you just saw me load into Mongo, those were generated by a program that put all that data together in memory and in binary. And then I said, yeah, but I want to be able to download it, make it human readable, be able to email it to somebody if I want, and for them to be able to easily open it. So transform it into JSON format and then give it to me. Same is true for transmission over the internet. And once we've done that, where we've serialized it into a text format and transferred it to whoever wants it, in this case, I put it to GitHub from my desktop at home. I downloaded it on this computer. It's the exact same file either way, and it's plain text. All of you can download it. We can send it back and forth in emails. When you're dealing with plain text, it's super easy and safe to transfer. And then it does take one extra step, but then you can take that text format or that JSON file and in whatever program you're using, every major language, as far as I know of, has a way to read JSON and write JSON because it's such a common format. In JavaScript, it's literally one command of JSON.parse, and then we give it a string, and it will turn that into in-memory JSON objects based on the JSON format. It's also commonly used to interact with APIs. I haven't seen any hard numbers, but I would wager that the vast majority of API interactions on the internet and internal to companies is done with JSON. SOAP and XML are still around, but they've been losing market share every year from what I've seen. So a very large chunk of the internet is already speaking JSON. So we're just integrating with that and we can take advantage of it. More on point for this class, that's how we're going to query and store data in Mongo. Again, there's a note of mostly here. I talked about BSON earlier. Truly behind the scenes, the files will be written in BSON, and we do have those extra BSON types we can use if we need them. But at the basic level, we can conceptually treat it as if we're dealing with JSON, because it's very, very close to the same thing. Already mentioned that it makes our JSON objects human readable because it's going into plain text format. The file I showed you a second ago, while it was human readable in that we could read all the text in it, it was very large and it was one long continuous line for each document. We will see that we can make that even more human readable here shortly. And since we're doing just plain text, you probably know plain text compresses really, really well. So if we write out a JSON file and then we compress it with whatever your compression algorithm of choice is, we can make those files dramatically smaller for transfer.
Hey, Cameron, just to add some context to this, generally speaking, tell me if this is not a true statement. Generally speaking, when you're looking at a web application, a simple web application that is pulling data from somewhere out there, you know, when you're typing in an order, say for a super simple e-commerce site, say the fields that you look at on your web page in your browser are populated via an incoming JSON file, correct? Isn't that generally
Yes. Yes, that
the
is very,
method
very
for
common.
it's the method for getting the stuff that your browser is putting on your screen from the back end and then sticking it in the right place on your website. And that's what a full stack developer learns. how to do. So it is the language of data transfer over the internet. I mean, to
So
the
I
tune of,
chose a random site. I chose news.google.com
yeah.
and to look at some of their stuff. And this is JSON. It's rather nasty JSON, but technically this is JSON. Let's see if there's any other of these.
But yeah, these guys aren't necessarily full stack developers. I just want them to realize that when somebody's writing a web page, generally they're going to write code that accepts a JSON file
Mhm.
and reads these fields out of it and sticks them on the web page for you, so that it looks, it looks right. But this
Yeah.
is the data transfer for the internet. I mean,
Yeah,
and
the main way that we build full stack applications these days, or even just regular web applications, is typically the best practice is to have one project that is your UI. Its only purpose is to present data. It doesn't know what a database is. It's just, this is the look and feel, and something is going to give me the data to present on this page. And that's where the API comes in. API, maybe it's backed by Mongo, maybe it's another database, but that UI is going to ask the API for the data it needs to be able to provide to the user. And it's going to do that with a API call. If it needs to supply information about what it's asking for, it will do that in JSON format. But when that API queries the data from whatever its source is and returns it to the user, returns it to the UI to display on that page in order to show name, address, or search results, any of that, almost invariably it's going to be JSON that is being transferred back and forth.
there you go.
So we have a simple example of a JSON document here. I'm actually going to cut this out and throw it into VS Code because the syntax highlighting in this browser is not great for a screen share. So this is what we see when we talk about a JSON document. In this case, what we're looking at currently, this entire file is a document. It currently consists of only a single object. Your properties, your objects, your arrays, everything in it always has to be wrapped in something. It can be an object, which is denoted by the curly braces, and that is both the most common and the primary standard. The reason that we had to do that one extra step when we did a Mongo import of our data is because it actually, instead of being wrapped in an object, it was wrapped in an array, which is indicated by square brackets. So that was the reason we had to take that extra step. It's still very, very common, but technically we should have, to be actually 100% compliant JSON, we should have had it open a curly brace and close a closing curly brace and all of our data in between. So I'm actually going to, before we talk about this vehicle object here, I'm going to add some simpler properties to this because I don't want to start by jumping into my first property we're talking about as being an object. So we treat this entire document as an object as a whole. Objects are key value pairs. Those values may be simple values such as a string or a number, or they may be more complex types like another object or an array. So let's start with a really simple one. We'll pretend that I own a Tesla since I've already got a Tesla in here, and we'll define a property with the name of name, and I'll put my name as a string property here. You'll notice that as I'm typing, VS Code is automatically validating this JSON for me because I'm missing a comma. These key value pairs are comma delimited. So it's already said you've done something wrong, and let's see what its error is. Expected a comma. Real easy fix, right? I'm missing a comma here. So effectively, everything needs to be enclosed in quotes, specifically double quotes, both keys and values, with the exception of numbers, Boolean values, and of course, objects and arrays are defining another smaller thing. So we've added a new property with the key of name and the value of Cameron. And let's do a number type. For those of you who have worked with strongly typed or statically typed languages, this might feel a little bit weird. If you've done a lot of JavaScript, you'll feel right at home here. We don't have to tell JSON what the types of our variables or our properties are. We just give it a value. So in this case, I've said there's a key named name or a key name with the value of Cameron. Since this value of Cameron is wrapped in quotes, it is a string. JSON or whatever parses this JSON is going to look at that and say, clearly this is a string because it's wrapped in quotes. Similarly, we have a key named age with a value of 37 that is both only digits and not wrapped in quotes. And so whatever parses this JSON is going to look at that and see, clearly this is a number, it will get a number type. This is true when you're working with it in JavaScript, as well as when we work with it in Mongo. If I were to insert a document that just contained these two properties, name and age, then Mongo would automatically assume that the name property is of type string because it sees the quotes, and it would automatically infer that the type of the age property is a number because it sees 2 digits and no quotes around it. And of course, exactly the same thing is true of our Boolean values. I'll use employed and a Boolean of true. Quick review in case you're not familiar with Boolean types. A Boolean type, its only purpose in life is to indicate a true or false value. In JSON, the static word true and its equivalent false, it is a reserved word, just like in most other languages, where when something is parsing JSON and it sees a unquoted string, or it sees the word true and it's not wrapped in quotes, it knows to recognize that I'm dealing with a Boolean value here. So those are our simple key value pairs and types of have a name with a string value, an age with a number value, and an employed with a Boolean value. That's all well and good, but where the power really comes from and where Mongo and document storage in general differentiate themselves dramatically from relational databases is that we can store objects and arrays. So again, this is still a single document, a single JSON document. Now I have a property named vehicle. And this is going to be, in this case, I'm saying that I can only have one vehicle, and the vehicle I'm going to have is going to be a object that contains other properties. So I can actually minimize this for a second. So we're still dealing with just key value pairs. Here our key is vehicle, but our value is a more complex type. Instead of it simply being a string, it's an object that can contain its own keys and values. So inside of this vehicle, quick review, we have the same things we did earlier where we have make, model, and year, as well as salvaged. Those have string, number, and Boolean types. And then we see another layer of nesting. Vehicle, its value is an object. And in this object, there's another property named authorized drivers, which is an array or a list of items. And that array can contain 0 to many different items. In this somewhat simple example, I've provided string values. It doesn't have to be strings. It could be numbers. It could be Booleans. Where things start getting even more flexible is this can be literally any type, which means that the items in this array could be objects. And those objects can have their own properties. Those properties could be arrays. Those arrays could have objects inside of them, which could have arrays inside of them. Actually, let's just start with a simple example. Imagine trying to represent this in a single table in a relational database. Dealing with arrays is very difficult with relational databases. Nested data, in fact, you would never do this in a relational database. You would have a table for vehicles and you would have a table for people. And if you needed to get the vehicles assigned to a person, you would join those two tables together. In Mongo, we don't do that. most of the time. We say this person only has one vehicle, so why don't we just store the vehicle with the person in a single document? If we're fetching the person, then we're fetching the vehicle potentially. And if we're wanting to know what vehicle somebody drives, we query that person and the vehicle is already attached to that person and we get that same data with no join required. So that is our full intro to where we get up to actually at this point kind of digging into Mongo. I need to start moving a little bit faster, I think. So let's get back to Mongo and onto our operators and then actually executing JSON queries against our data. So I mentioned Compass. I would recommend it. Robo3T. VS Code has a very, very basic one that you can download as an extension, but I'm not that much of a fan of it. So I'm going to go find and open Compass. It's pretty self-explanatory, but if you're running locally, by default, it's going to default to connecting to your local host, just like the Mongo CLI did. So I'm just going to hit connect. It's going to show me that database that I created earlier, ACDS, and the collection named people. It will automatically query a few records just so we can look at them, and it will show us a lot of helpful information, like it's showing us documents 1 through 20 of 1500. But now we actually want to start querying against this data. The simplest query is a find, and that is the equivalent of a select star from in a SQL world. The primary difference, besides the fact that everything is different, is that instead of saying from table or from collection, the collection we're going to query is part of our command before we even get to what we're defining we're searching for. So if I wanted to, let's just take this person here. So I know that I'm querying something easy. The full query, and Compass makes this a little bit easier for us. I'm going to write the full query and then I'm going to do it how Compass wants us to do it. If I was executing this on a command line or in code somewhere, I would say db.people.find, and actually if I just wanted to say give me all the records, that's what it would do. This is a select star from people equivalent in SQL.
So that's like an object method like we were used to using in Python, right? I mean, basically the syntax or the way to think of it.
Yes, exactly.
Cool.
And the reason this is red here is because since Compass knows I'm working with the people collection or the collection named people, I don't have to say db.people.find. This window or this section here is specifically reserved for executing find queries. So all I really have to give it is the where clause. Again, SQL equivalency. I need to give it a where clause. And the way this is structured, as you can see in this example behind the scenes, although a little bit dim, so I'll get it over here shortly, is we, in JSON format, provide an object that is our query. And inside of that, the simplest structure is we provide the name of a property or key or field, and then the value that we want to find all the records that it is equal to. So as I said, I just grabbed this person's first name, Ives. So if I was going to write a query to find everyone in this database whose first name is Ive, I would, again, it's a JSON document, so I'll always start as an object. And the field I'm querying for is, again, in SQL speak, I'm saying select star from people where first name equals Ives. So the name or the property that I want to filter on is name, first name, and I want to find all the documents where it is set directly equal to the word Ive, and this will be case sensitive in this case. Apparently we have 2 of those in our list of 1500 people. So that is the simplest query you can possibly run. It is a basic equal of this property in this document or in all these documents. Return all the documents where that property equals this static value. There are multiple ways to write a straight equals. This is the way most people do it. There is also a equals operator where you can be very explicit. If you're just doing a top level filter like this works fine. You can also chain these, and we're going to be talking a lot more about operators, but you can also chain these where, again, I'm writing a JSON document and I'm saying I've got a key of first name, a value of Ives, and I also want to put a key of last name and a value of Geradeshi, maybe. And so we had two documents that matched on that first name. And because I can look down here and see that this other document is not going to match on last name, if I hit find again, it's going to filter down to only documents that match both a first name of Ives and a last name of Geradeshi. We can, of course, keep adding to that if we want it where it's first name of this, a last name of that, a state of this, a zip code of this, email of that. Just keep adding them, and these are just select star from where field 1 equals this, and we're doing logical and here implicitly, and last name equals this, and state equals this. We will see very shortly how to do explicit ands and also logical ors. The only other thing that I want to show you about this very basic query structure is that there are two main parts of it. There is the filter, which is what we've written here, and you can see it's indicated by filter and compass. But there is also a projection, and we'll see that this word again, project or projection. Projection is, you know how in a relational database or in SQL, a table may have 100 fields or 100 records on it, 100 columns, that's what I'm looking for. A relational table may have 100 columns on it, but you only want to query 3 of them. So you may say select field 1, field 2, field 3 from table. Projections are how we do that same idea in Mongo. It is separate from our filter, but it works almost the same way where, again, we provide a JSON object and we say, I only want to return, say, the email property. These are kind of Boolean values. Mongo is for indicating the flow of a command. It often uses a 1 or a -1, somewhat as the equivalent of a Boolean true false. So at this point, I'm saying email 1, meaning I want you to return the email field to me. And let's say I also want IP address. So if I've done this correctly, I'm still filtering on this first name and last name, so I'm only going to find this document, but with my projection, I should now only get the email property and IP address properties returned to me. And that's what we end up with. It's a good way if you have large documents and you don't care about most of what's in it. Say I only wanted this guy's IP address. There's no reason for me to return every bit of data I have about him. I can just say project IP address equals 1 and I will get that single field back. Any questions over our basic filter and project before we start getting into some more complex bits?
I just gotta say this is so cool. This is incredible. Remember, because guys, you gotta set up a relational database. You got to decide the rigid structure, the columns, the rows, the relationships, and all that, because JSON is self-describing, with the key and the value, and then the nesting and whatnot. This is magic. I feel like I'm watching sorcery right now. And the fact that it handles this data and performance. It's not just like searching through a text file using some rules every time. It would take forever. It's just to me, I don't know. It's pretty incredible.
It's pretty amazing.
But
when I first got into it, I was like, why haven't we been doing this for decades?
So Cameron, your background is traditional relational. I mean, you got like 20 years in the field, right? NITs?
Yes, I was almost 100% relational up until about 2015, and that's when I moved over to the web services, Node.js, and Mongo side of things.
Okay. So, and it took you a little while to start speaking correctly as far as, or speaking NoSQL versus relational.
It did, but I always had a pretty staunch dislike for SQL. I was never great at it, so it was an easier transition than it might have been otherwise.
It was a rejection, not a transition.
Exactly.
All right, I'll stop wasting your time. That's cool. Oh, but I wanted to know if there was something like a function where you would say like only return, like you had said, I think it was authorized driver in your one document, your test document. You had 3 authorized drivers. You know, you when you're querying stuff, a lot of times you want to know when something has more than 2 of something or more than 10 of something or whatever as a subordinate. Uh, so I got my eyes peeled for that kind of stuff, but I'm sure
Yep,
it's
we will
gonna
definitely be seeing that.
cool. All right, I'll shut up.
Uh, just a quick side note, switch back to this. You'll notice this field, the underscore ID field, that's not in my data. Mongo automatically adds that to every field if you don't specifically provide one. It is a internal unique identifier. It does actually have some useful data encoded into it. I think it's got a time as well as the shard or node that actually accepted and handled the insert of that record, excuse me, document. We're talking a lot. I'm comparing SQL and NoSQL a lot, and I'm starting to blur my terms. I apologize about that. You can specify your own underscore ID field. From my experience, most people don't. They just allow Mongo to do their thing, but then we will often create a new ID field, specifically ID, not underscore ID, that we will use as a unique identifier, like a UUID or a GUID or something like that. But the reason I mention that is because you see it even though we didn't insert it. And also the reason I mention that is because it's quite common to, if you're querying this data from an API and returning it to a UI or a web page, you probably don't want to include that underscore ID field because it means nothing to them, most likely. I can't think of a good reason it would. So it's also very common in our projections to say, not only do I only want field's email and IP address, I also specifically want you to not include the underscore ID field. I mentioned these work kind of like Booleans with a 1 and -1. So if we're wanting to include a field, we say 1, or field name 1. If we're wanting to suppress a field, then we say -1. So while it automatically added this ID field in our result set, if we project underscore ID -1, it will have actually run into I was not expecting that because, again, I'm not super familiar with Compass, but I am very used to suppressing. Oh, wait, is it 0? Okay, it was 0. Sorts use 1 to describe ascending and -1 to describe descending. When we're talking Boolean values, and this does make more sense, of include this field or do not include this field, I misspoke. It is 1 for true, include this field, 0 for false, do not include this field, or explicitly exclude this field. So sorry about that confusion. Very, very common to use your projection to suppress the underscore ID field when you're returning data to, say, a UI. In the interest of time, we've already covered this where we can specify multiple statements where we said, I want the first name property to equal this, the last name property to equal this. And while we've not explicitly put an and here, we didn't say where first name is A and last name is B. We just listed those properties. That's called an implicit and because it is doing an and it's making sure all of these query clauses are true, but we didn't have to specifically put the word and in there. However, when we get to more complicated queries, we may need to do that. And the way that is done, let's see if that's done to talk about it now. We'll talk about it in logical operators. So just know if you just list property value, property value, property value, that is a logical and implicitly, but we can also explicitly define an and, especially when we start doing really complicated things, like saying these three things all must be true, so logical and, or these four things must be true. And so we're building two groups of queries that are logical ands, and then putting a logical or in between them. In those cases, you cannot do an implicit and. You have to explicitly say, I'm anding these query clauses together. So just like we can store nested documents in arrays, and I'm going to remove my projection and my query. So we've got our favorite colors array. This person only has one color, but they have an address object that contains address 1, city, state, zip code, an array of hobbies. Clearly, we want to be able to query on these things because we want to say, maybe I want to find everyone in my database who likes the color khaki because I'm going to have a sale on khaki pants or something like that. Or I need to know everyone who lives in Arizona, or everyone who enjoys computer programming because we're going to have a class. So what we've seen so far is we've only queried the fields that are in the very root of the document. We use first name, last name, we use email and IP address. What if we need to go deeper? What if we need to get into nested fields? It is extremely simple. The only warning I need to give you is in my last example, I did not wrap my key, the name of the field that I was querying, I did not wrap it in quotes. It's recommended but not required. However, when you start accessing nested properties, we're going to have dots or periods to indicate the parent and child relationships. In these cases, you must wrap them in quotes or it's just going to error. So let's say I wanted to, let's use the Arizona example. I want to find everyone in my database who has a object named address with it that also has a property named state that has a value of AZ. So again, we must wrap this in quotes, and we would reference the address object and the state property of that object and say that I only want results for that exactly equals the string AZ for Arizona. So let's blow this up and let's see how many people, again, we got 1,500 total documents. Let's see how many we've got in Arizona. So 31, not too bad. Our same guy keeps coming up over and over due to natural ordering, but we can fix that later. I'm just going to spot check one or two, make sure that Chicky is in AZ. What about Nanetta? Also in AZ. So we can see that out of our 1,500 documents, we have 31 of people that have data representative of living in Arizona. That is how we access the nested properties of objects. So again, we were looking at address, which is an object, and we just said address dot property we're interested in. What about arrays though? Let's use hobbies because I think I have more data in hobbies than I do in favorite colors. I should also take a moment to note that when we say address.state here, if we're working in a programming language and we don't have a property named address and we try to access state on it, it's going to error on us, right? Mongo handles that internally. It basically says, does this document have an address property? It doesn't. Oh, well, then clearly it doesn't have a state property either, so this one doesn't match. And it just moves to the next one and says, does this one have an address property? It does. Does it have a state property? It also has that. Does it equal to AZ? It does. It matches this query. So you don't have to worry where if you're writing this in code, you have to worry about null pointer exceptions and all that extra checking. That does not apply in Mongo. It either exists and potentially can match the query, or it does not exist and therefore it clearly does not match the query. So I just take a quick aside to point out that you don't have to worry about hitting exceptions with that, but we were about to talk about how do you find, if you have an array that contains 0 to many items, and we want to know which users or which documents contain a single item or have an item that equals a value I would like to query on. Very simple and very similar to what we've already seen. In our simple case, we simply reference the property name, which in this case is hobbies, and we say programming. And what this is going to do is it's going to find every document that has an array named hobbies and that has at least one value inside of that array that is equal to programming. So we've got 155 records where, scroll down a little bit just to spot check one. We have this person, Salem, has 3 hobbies. They are soccer, exercise, and programming. And so it matches what we asked of, does it have a array named hobbies and does it contain the value programming? And one tiny bit of clarification, what I just said there was, does it have a property named hobbies that is an array? It doesn't have to be an array because this is the exact same way we queried just a plain key field. So if there was another document in this database that had a basic key named hobbies and it was assigned the string of programming, that would match as well. So that is, it's nice because it's super flexible and allows us to easily search inside of arrays, but you have to keep in mind that if your data is not well structured, because it doesn't have to be, then you can run into situations like that.
That did bring up the question, if you don't know if you got the object dot attribute wrong, like the previous example you had address dot state or whatever. If you misspelled state or got the, you wouldn't know if you got the you wouldn't know if you had the state attribute spelled wrong or if you use the wrong state code. Either one is going to give you no records. So
Right.
that's you don't get a syntax error like you might
Exactly.
in, you know what I mean, in a
Yeah.
programming language.
It's really nice because it's flexible.
Yeah.
But with flexibility can come danger.
With great power comes responsibility.
So let's talk about comparison operators.
What do we think? It's 10:20.
Ooh, yeah, this is a good time.
Do you need a boogie or can we take 10?
What about 5? That'll give me enough time to refill a drink.
5 gives me, yeah, you're on record. So if folks need to take longer, they're, but when we come back, take questions. 10:25.
Can do. Thanks.
10:25.
All right. So Don helpfully reminded me to ask for questions. I got on a roll and forgot to pause and ask. Any questions at this time?
Earlier, when we were looking at that vehicle example, you said they only have one vehicle. If they had more than one, would you make vehicles an array of vehicle objects, or?
Exactly. And our query would work exactly the same way. If we said, if we queried for vehicles, we'd probably name it vehicles plural if it was going to be an array because it can contain more than one thing. We would say something like vehicles vehicles dot make equal to Honda, and it would work exactly the same way. If the vehicles array exists, it will look into it and it will check and see if there is at this point it has to be an object because we're saying that the value inside of vehicles is going to need a property named make, and the only way we can do that is with an object. So it checks to see if that exists and is an object, and if so, and that property exists, then it compares it to Honda and gets us the same end result.
Yeah, that's critical. So somebody with the last name Honda or whatever, it's not gonna just go looking for that search term anywhere.
Right, it has to be exactly, and everything leading up to or that prepends this field has to exist in order for this to become eligible to match. And then that exact field that you specified has to match it as well.
I assume that there are ways to count how many objects are in an array, right? So if I wanted to check, like if I wanted to check who had like 2 cars or who had 4 cars, right? And then sort of by that, there's a way to do that.
Yes, I believe I have a section on arrays specifically, and there is, if I'm remembering correctly, a size operator that will return the count of the number of items in the array. That does bring up an interesting point, is the Mongo shell that we looked at earlier is effectively just a JavaScript interpreter. So if you have a query that you need to execute that is somewhat programmatic, like you need to loop through things and then do queries based on those loops, you can actually write JavaScript that executes directly inside of Mongo, and it will interpret your JavaScript and execute it as defined. And instead of executing a single query, you can execute a bit of logic that executes 1, 2, 3, 20 queries. Clearly, you're going to run into efficiency issues if you're working on a very large database or collection in that case, but it can come in extremely handy. And of course, JavaScript has a .length operator for arrays and things like that.
And you don't have to learn another scripting language to do that. So that's smart.
Yep. So any other questions before we move on to our operators? All right, so this is where things syntactically start looking a little bit odd. These are our operators, and you'll notice they are all prefixed with a $sign. All Mongo operators have a $sign in front of them. When I first saw this, it threw me for a loop until I dug deeper into the JavaScript language and realized that that is a perfectly acceptable JavaScript variable name. They can contain $signs, and they can even start with $signs. And so what Mongo has done is said, so that it's easy for you to tell what all of our operators are and where you're using them, all of our operators will be prefixed with the $symbol. So we're going to do examples of these, especially the more interesting ones, but I'm going to hit most of them pretty quickly because they are your basic comparison operators just used in Mongo instead of a normal language. EQ, of course, is equality or equals to. So we've already done the implicit and the implicit equal, where we simply said, find me another example here, go back with our guy, where we wanted to find everywhere where first name is equal to this exact string. And I've messed up my copy paste. So this, if we had another field here, then they would be implicitly ANDed together, even though we don't specifically put an AND operator in here. But we've also done an implicit equals operator here. This is the way most people do it because it's super fast and easy to read. But we can do this exact same thing in a more explicit manner. And when we get into very large queries, oftentimes we are forced to, just because of how the syntax starts to work out. We saw, or we will see, that we know we provide the name of the property we're wanting to compare to or query on. And then if we put curly braces after that, then everything inside of that is the operation or comparison, the operations we're going to apply during this query specifically to this field that was before it. So anything I put in here is going to be applied to first name. And if I wanted to explicitly say I'm wanting to do an equals operation where first name equals this string, then this would be the way to do that explicitly. The only reason I really show this is because most of our other operators, we have to do it this way. Equals is just the one that they give us a convenient shortcut where we can just say name value, and it understands we're asking it to do an equals. So if I hit find, I should get exactly the same results. And I do 2 documents, same people we've been looking at so far. I'm going to lump GT, which is greater than, GTE, greater than or equal to, LT, less than, LTE, less than or equal to. I'm going to group those all into one example because I'm sure everyone is intimately familiar with how numbers work and which numbers are greater or less than or equal to, greater than or equal to. So all of these operators work exactly the same way. Let's use age. So I've got an age field that is just a number. What if I want to find all documents where the person's age is greater than 30? I am basically, since our query type is going to be very similar, I'm not going to erase this and rewrite it. I'm just going to switch up the properties and operators. So now instead of working on the first name property, I want to compare to the age property. And I said I wanted to query where the age is greater than 30. You can also see that Compass does have built-in autocomplete to help us with our operators, which is pretty nice. Of course, I can't say, is the age number greater than a string? That is not a logical comparison. So I need to provide it a number to compare to. And I said we were going to look for 30. So this should query all documents in my database where the person's age is greater than 30, which is most of them, because out of 1,500, 1,117 have that age, or have an age greater than 30. When we look at our logical operators of and or, I'm going to come back to the same example of age, and we will look at, I want to know everyone in my database who is older than 30, but less than 40, and pull that segment out. But we'll finish up with our comparison operators first, and then we'll move to that. So again, less than equal, greater than equal, all of those function exactly the same way as we just saw here. In and nin, or 9-inch nails if you prefer, these are operators that are very similar to JavaScript in how we ask if, well, actually, and SQL. SQL has this the same convention, if I remember correctly. I know it has in. I think it has nin. This is where we can compare to a property that maybe only has a static string value, but we want to say, does that value exist in this list of things that I'm querying against? So I'll go back to first name since I have a new person here. I haven't seen him on the top before. So I want to say that I would like to query all my documents in this database where the first name is in. Whenever we talk about lists or lists of things in JSON, we're always talking about arrays. So since I'm saying that the first name needs to be in this list of things, the list of things I provide it needs to be an array. So I will declare an array here with our square braces or square brackets. And then I will put a list of first names in here that represent all of the names I would like to query out of our database. As you can see already, this is a pretty simple query. It's one property with an in operator and a list of things to compare to. And when it comes to braces and brackets, it's already getting a little bit hard to read, and it's going to get way worse. And this is why I highly recommend a JSON editor for writing your queries initially. So we'll go back to our guy Ives because we know he's around. I see the first name of Cobb shortly below us, and let's just choose one more at random. Let's use Jeffy. So just because I remember that I know there are two people in this database named Ives, I know we're going to get 2 records for that name, and I know there's one for Cobb and one for Jeffy. So we're going to get a minimum of 4 records, but we may have more instances of Cobb and Jeffy. We'll just have to find out when we execute it. Apparently not. We have 1 Cobb, 1 Jeffy, and 2 Ives. And just to do the flip side of this is we just queried for everyone who has a first name that is in the specific list. But if we want to query for everyone who is not in that list, we don't care about Ives, Cobb, and Jeff anymore. We want everybody besides them. We simply switch our in to a not in or a nin, and it inverts that query. And now, since we got 4 documents that match the in, we should get what, 1496 that match the not in. And I actually did my math correctly, so it's a good day. And I'll cover not equals super fast. You can probably assume what it is compared to equals, and then I will pause again for operator questions. So since our equal operator, let's say we were using Ives, the not equal operator, of course, is just the inverse of that, is everything that is not equal to this string I'm comparing to. So we changed it from equals to not equals, and now we should get 1498, which we actually do. So any questions on the comparison operators that we've covered?
Cameron, I was just wanting to ask you if I could have a copy of that data file, that randomized data file that you're using there.
Yes, it should be in the GitHub under
in your
data.
GitHub? Okay, cool.
I will point out that there are these two, ACDS data 1 and data 2 are the ones that I've loaded. If we get to geoquerying, then we'll talk about the combined ACDS data with coordinates.
Oh, cool. I can grab it. You got all those links in the chat, and the chat gets recorded automatically. So
yes,
I got it. Thanks.
All right, so we talked about how to compare things. What if we need to do multiple comparisons? We need to say the example I just gave about age of we want to query everyone who is older than 30 but younger than 40. That would be and logically, we would search for greater than 30, logical and age less than 40. By far our most common logical operators are and or. We use them all the time in programming. Clearly slightly different syntax for Mongo, but they function exactly the same way. So I told you we would write that age example once we got to our logical operator, and now that we're here, let's use that as our example. And you know, I think I actually am going to write this one in VS Code because it's going to grow by several more braces. So let's do that over here. Also, while you can use new lines or carriage returns in Mongo Compass, you obviously have a lot more room to work in an IDE, so that's where I prefer to do it. So I want to query where age is greater than 30 and age is less than 40. So I'm going to start with my and operator. This is the downside of working in an IDE because this is not technically valid JSON. It's valid JavaScript, but not JSON. So VS Code is going to complain that you don't have this in quotes and it has to be. I'm not sure what happens if you put quotes around operators in Mongo. We'll test that here in a second because I've never done it, but if it works and I could avoid the error checking in VS Code, then it might be worth the extra couple of characters. So our logical operators take an array, even if you only give it one item, it can have 0 to many. And so as a way of just structuring this query out, I've declared my and operator, created an array that we're going to put all of our logical comparisons into it that we want to logically and together. And sometimes, especially if I'm writing something really complicated, I may start with a little bit of pseudocode and say age greater than 30, age less than 30. Clearly, this is not valid Mongo syntax, not even remotely close. But if I'm writing complicated stuff, See, I've already screwed up. I've said age greater than 30 and less than 30 when I really meant to have age less than 40. I typically like to go through and pseudocode my complex queries first, and then I go through and actually start filling out the guts of it. It keeps me from messing up my braces or getting overly confused and mixing things together. Probably the worst query I've ever written. Well, I'll say longest query. I don't know if it was the worst, but it was the longest. Was when written out in easy to read, well formatted syntax like we see here and fully complete, was about 400 lines long. So you can imagine I can't fit 400 lines on screen. So there were a lot of comments in it that said what each section did and how it worked. Keep that in mind if you start having to write long, complex queries.
And that 400 lines was just the criteria for a query.
It's that, to be fair, that one was an aggregation pipeline, which we'll talk about later, which is the equivalent of like a group by or a partition in SQL.
Yeah, but
So
still,
Mhm.
I mean, it wasn't an application. It's not like you had looping
Right.
code or anything, and that was just, wow, there you go. And I think SQL guys get into similar craziness as things get super complicated and
Oh yeah.
lots of tables and lots of conditions. Okay, shh, Don, hush, Don.
So I've got my objects here where I want to define the query of age greater than 30. So I will use my property name that I know is age. Again, the quotation should be optional here since I'm not using a nested object or anything. Just to make my editor happier, I'm going to go ahead and put them. Best practice is probably to use quotes all the time. And now that I know I'm referencing the age field, I need to do my comparison operation on it, which is I wanted it to be greater than, and I'm actually going to do greater than or equal 30 because I want to include 30 and up. And our next one down is basically the same thing, only we're going to do less than or equal to 40. So I need to define that I'm going to be applying this to my age property. Define the object for my comparison operator. And actually, in this case, I will just use less than because I want to get everyone who's in the 30 range. So that includes the age of 30 all the way up to 39, but it does not include 40. We're gonna exclude them. So one more quick review on this, then we'll execute it. This query, we start off with just a logical and it's going to say everything inside of this array is going to be evaluated. And then I'm going to logically and those together. So every single one of them must evaluate as true in order for this statement to evaluate as true. So I'll paste this in here. Again, we can do new lines. It's just a little bit more difficult to work with Compass. And hit find. And we have 153 documents of people who are in their 30s. So just a quick spot check to double check, age of 37, 34, 36, 33, so looking good. I said and or are our most common logical operators. So let's also look at and real fast. What if we wanted to do the opposite of what we've just done? Instead of saying, just give me people who are in their 30s, I want to find everyone who is not in their 30s. So we could, there's obviously multiple ways to do that. Since I want to demonstrate a logical or, I'm going to say query everyone who is less than 30 or is greater than 40. This is actually really easy to swap out because the and the or operators work effectively the same way, and at least they're structured the same way. Clear that. In that we write the operator name and we give it an array. So I'm just going to change my and to an or. And we want everyone who is less than 30 or is greater than or equal to 40. So this should give us everyone in our database who is not between the ages of 30 or who is not the age of 30 to 39. And again, we'll do our quick scroll through. We got someone who's 8, clearly under 30, 81, clearly over 40, 19, 108, 50. So looking good. So again, our and or operators, they work exactly the same as every other language. Our syntax is just a little bit more complicated because of how we have to write it from Mongo. Not is, again, a logical not. So you could say, is this clause true? I'll go back to age. I want to evaluate age greater than 30. We can wrap that in a not operator that will then invert it. If you're used to most programming languages, this would be the equivalent of putting an exclamation mark in front of a Boolean evaluation. Nor, I don't actually know a language that has a nor operator in it. Potentially I'm just ignorant of it, but I've not seen one. And it is a not or. So is this first thing true? Is this first thing false? Nor the second thing false. So it's kind of like a logical compounded not, but it's so, I've never honestly seen it used, and it may just be because it's not very widespread, so it doesn't get a lot of use. Which reminds me, we need to talk about the MongoDB documentation because it is pretty great. If you have a operator that you want to learn more about, like I just barely hand waved at nor, then you can go to mongodb.com/docs, type in your operator, and see everything about it. So performs a logical NOR operation on an array of one or more query expressions and selects the documents that fail all of the query expressions in the array. Like I said, their documentation is really good. Almost every single, as far as I know, every operator has sample data provided with it as well as sample queries. So it's very easy to grasp and understand. So anything that I'm not clear about and we don't have time to cover, that's a great source. On our element and evaluation operators, I'm going to go through these pretty quick. The one that I use all the time is exists. And that is, earlier we said compared to this field, and if it doesn't exist, well, clearly it doesn't match. If we want to find out if that field does exist, or if we want to retrieve all documents where this field exists, this is the operator to do that. This comes in very helpful when you do have somewhat unstructured data, or at least non-consistent schemaless data. Or I've had to use it in the past because we at one point adhered to this rough schema, and then we evolved that schema and added a couple of fields. And I needed to know all of the records or all of the documents that were added at that time when we started adding this field. So I query the database where exists this new field, and I know that that is all of these documents were added at that time when we evolved the schema. So I definitely will do a quick example of that. I don't recall what I set my null factor to when I was generating this data, but I can also just pick a field name that we know doesn't exist. So I think maybe I set gender to have a null percentage. So let's test that out. This query will tell us whether or not I did that. So we choose our field name and then write our curly braces for where we're going to put our query for that field and say exists. Let's go with false. We can choose to query documents where that field does exist, or we can choose to query documents where that field does not exist. So what I'm doing now is saying query all documents where there is not a property named gender on that document. And apparently in my data, the gender field always exists. I think maybe sometimes it's null, but it does always exist. So just to show the example of just querying for a field that doesn't exist. Let's query for a field called favorite album, because I know this does not exist. So we should get 1,500 records back, and we do. And just to show the difference as one extra bonus, I'm going to manually modify this one document, and I'll give it favorite album since I already wrote that. I can't think of a good one offhand, so I'm going to use test. So we know from searching where favorite album exists true that we previously would get nothing, because I knew that was a 100% generated field, or 100% non-existent field, because I didn't add it, and we would return 0 records or documents. Now I've manually modified this document to include that property. So if I hit find now on favorite album exists true, I should just find this one document. Yeah, just this one.
Hey, Cameron, you were gonna, did I miss it? Because I do have to admit, I've looked at a couple of things to check something while you were doing this. You're making my brain go crazy here with possibilities. You were going to check to see if you put an operator in quotes, if it would
Yes,
error
let's
or
do
not.
that.
You didn't do that, did you? Okay.
I did not. Good question.
Mm.
So we can do that with our exist one. Apparently still works. So that means that
Over in VS Code, you could make it pretty.
So let's try it with a more complicated query. If it works for exist, it should work for all of them, but let's.
And that had not occurred to you, but isn't it crazy how when you're teaching something, things occur to you to go, you know what I mean? And now you want to check it and kind of go off script, and yeah. So it's not just me, guys.
Yeah, and that works perfectly. So if you're writing long, nasty queries in VS Code, if you wrap your operators in quotes, it still functions exactly how it should. And now you truly have a well-formatted JSON document. All right, so I said I was going to hit these pretty fast. Type that operator will tell you the type of that property. So if we said type of age, it would return number. Specifically, if we look at compass, we can see what that type is, age, and it's just a int32 is what it chose to store that as. So if we did type of age, it would return int32 to us. Mod is the modulo or modulus operator. Actually just taught that in my JavaScript class last night. I love that operator. Don't find myself using it in Mongo much, but it's a good thing to have around. Regex will allow you to apply a regular expression to a field or to a property. And I actually am going to give you an example of that, because that is the regex operator, but just like we have the implicit equals, where if we just say field name : value, it knows we're asking for an equal. We also have that with regex. So what if I wanted to, with a very, very simple, fast, easy to write regex, actually, I'm just going to use BBB. What if I want to find all documents where the email contains the string BBB? And I specifically chose BBB instead of BBB.org, because I don't want to have to deal with escaping the period in a regular expression. So we can search for, we're going to apply it to the email field property. And instead of doing double quotes like I normally do, we treat it like a regular expression. We put our double forward slashes in, and then we write our regular expression inside of this. Again, super simple one. I'm just going to do a textual regex search for BBB. And apparently this is the only document that actually contains that. So that is the quick and easy way to do regular expressions when you're just saying, oh, I need to find all of my products that contain the word house in the description. Obviously, you can get into trouble with performance on regular expressions, but it is an option. That example leads me directly into the text operator, because it is specifically for searching text. However, need to be super clear on this. The text operator will only work if you declare a text type index on the field you're going to be searching on. If you have large amounts of string text data that you do need to search, say, again, you have a web store that has lots of products and descriptions and keys and tags and all that, then you might want to have the description have a text index on it. So when a user types in the search box on your site, you can do a textual search of that description. Text is the text index along with the text operator are designed to be as fast as possible. It does eliminate a lot of our non-words in English. Like it would ignore the word a and the word the and simple words like that. And I forget how complex it goes before it actually turns into real words, but it removes a lot of the stuff that you would never be searching on or would not be useful in a search and focuses on the more important words. Where, quick hit, I will refer you to the MongoDB documentation if you ever find you need this. You can use the where operator to provide a JavaScript text or a JavaScript code to Mongo and let it evaluate it inline. It's kind of an odd setup. I've seen one situation over the past 7 years where that came in really handy for us, but it's a little bit out in left field. Any questions on any of our element or evaluation operators? All right, array operators, this will be really fast. All means that we, first of all, when I say array operators, it means I know I'm going to be working against an array. Earlier, when we said something like hobbies, programming, this could be searching an array for this string, or it could be finding a property that simply contains a string named programming. It works either way. When we're dealing with these operators, we are specifically always working with arrays. Someone asked about finding the size of our array earlier. Size will get that for us. What all is, and all is a search for an array, but that array must contain all of the things I'm listing. So it's kind of like a in, but it has to contain all of the things in my list. So if we were to say, we want to search hobbies, and I want to find people who have all of these specific hobbies. I know I've been using programming, and I think I've got camping. So let's see if anyone enjoys both programming and camping. And apparently 20 people do. Camping, football, and programming. So it doesn't have to be an exact match in that the array can have other items that we don't specify to search on, but it has to contain all of the things that we did specify for it to search on. Let's actually take a quick look at the size operator because I think I may be confusing it with another one. Okay, I was in fact confusing these. So this is, well, there is a way to get the size of an array as it exists in the database. This operator, and that's what I was thinking about, this operator is matching based on a size. In that I'm saying query all documents that has an array named hobbies, and that array size is 2. So this is a comparison operation on an array, only for arrays that have a size of 2. And apparently we have 311 of those. So sorry, I misspoke. I was confusing this size operator with the one that gives us the length of an array. Luckily I caught that. LM match, I am mostly going to skip in the interest of time. It will search an array and you provided a list of things that must be true. and every item in the array must evaluate true for every query criteria you give it. All right, we're going to skip anything related to JavaScript because you guys don't care about that. We're going to talk quickly about indexes because indexes are very important. And then that'll probably get us close to our next break time. And then we will finish out with aggregation because aggregation is, there's a lot of power in aggregation. It's kind of like grouping and partitioning and windowing in a relational database, but you probably need to have good indexes before you can do a good aggregation pipeline. So let's take a peek at indexes. Oh, and quick pause, anything over that last lesson that there are questions with? All right, I'll be very brief on the purposes of indexes since I'm almost positive you guys have covered SQL in the past, that you are familiar with indexes, and they serve the exact same purpose in Mongo.
Only in theory.
Oh, in theory. Okay.
Yeah, we've talked about how creating an index makes searching on that indexed element faster, because of a binary search versus having to just troll through the entire list, but only just in passing.
Gotcha. And that's about the level that I'm going to hit here. So great. It is. One of the examples I use in class is treating it like the index of a book. If I'm looking for a topic on chickens in a book, I don't have to read every single page of the book to find where the chickens are at. I can go to the index and it says go directly to page 23. I go to page 23, and that was dramatically faster than searching the entire book. In MongoDB, they are stored ordered. So every index is going to have an order, whether you want it to or not. It's going to be there. It will default to an ascending order, but you can tell it to change to a descending order. And the order can be used for sorted results. So if you know that, using our people example, say we're very frequently going to query them and then order them by their age for some reason, we might have a index on the age field that is sorted ascending if we wanted to sort them ascending, because sorting procedures can be somewhat costly. But if your index is already sorted, then you don't have to perform the sort. You can ask Mongo to give you a sort, and it will look at the index and say, oh, well, this stuff is already sorted. So here you go. It's already in order the way you wanted it. So if you find yourself doing much sorting, you should probably be using an index on those related fields, and your index should be sorted the same way you want your data sorted on output. I mentioned the _ID field earlier. I did not tell you that there's an index on it until now. Mongo will always create an index, a unique index on the _ID field, and it's also always going to populate that field. It's just there. Most people leave it. Most people also allow Mongo to generate its own value for it because it does occasionally have some significance for us. But then typically we would generate our own IDs and that are significant to us, and then create a new index on that because that's what we're going to be querying by. It would be very rare to query by an _ID. You can see in the sample data here that I have a field named ID that has a UUID if you're from more of the open source world, or you might potentially call it a GUID if you're from the Microsoft side of things. Same idea, a globally unique identifier or a universally unique identifier. That is the first index we're going to create. After we talk about the different types, is we're going to create an index on ID because that's how we're going to query things. Because when you think about specifically in the context of web services and APIs, sometimes I do want a list of all the people in the database, but also if I want to edit one or view the details of one, I'm going to give you the identifier for it. So I'm going to say, give me person F681BC, give me their details so that I can update their address. And since we're querying based on ID, we want an index so we can query it very quickly and not have to look at the entire collection. If you guys covered the explain plan in Oracle or all relational databases, there is one in Mongo that works almost exactly the same way. All of the data you'll see is going to be dramatically different from what you're used to in SQL, but it does the same thing. The query planner, when we write a query, Mongo will run it through the query planner and it will decide on the most efficient route to execute this query. And I should put a caveat on there. My point here, it says it chooses the most efficient way to execute it. It chooses the most efficient way it thinks it can execute it. It's been a long time. I did run into this when Mongo was still pretty new. I haven't in a long time though. I ran into this all the time in Oracle, where Oracle has the same thing, where it looks at your query and says, here, I think this is the best way to execute this fastest. And it was super, super, super wrong, to the point of a query that would never, ever complete in 1,000 years. But if we went in and said, yeah, Oracle, I know you think that, but trust me, do it this way, then it would run in 5 minutes. So that's just there as a warning. Again, I haven't seen that problem in Mongo in a long time, but I'm also not typically dealing with billions upon billions of documents, typically just metadata. So it is a thing to keep in mind just in case. So when you start writing complex queries, run them through the explain plan and see what Mongo is choosing as far as the most efficient path it thinks to take. Another interesting tidbit on that is that when it chooses the efficient execution plan, it actually caches that, at least for a certain amount of time. I think it's configurable in the database. The important efficiency boost we get there is if I have this one query that is, say, reasonably complex, and Mongo runs it through the query planner and says, this is the best way to execute this query, then now, as long as this is cached in memory, it doesn't have to run it through the query planner again. So if we're running the same query over and over because a user is querying an API that's running the same query, we evaluate it once, cache it, and then use that same plan over and over. I'm going to do this very quickly. So in Compass, there is a tab for explain plan. If you were doing this via code, you just write your normal query and then throw a .explain on the end. So since I've already got this query written here, let's just explain this query. You can see it's doing a col scan or a, excuse me, column scan. This is the least efficient, excuse me, that's collection scan, not column scan. Once again, mixing up some of my terminology. This is the least efficient way that you can run a query. If you have a query that is, you're going to be running it a lot, or it's a time-sensitive query, if you run an explain plan on it and you see col scan, you are probably in trouble, and you probably need an index to fix that. You can see up here in our query performance that it had to look at every single document in our collection, all 1,500 of them, which is what col scan means, is that it had to scan the entire collection in order to determine the result of this, this query. And after we talk about the types of indexes we can have, we are going to add an index to that collection that will help speed up our times. And we'll definitely do it on 9D, but age was already there. So the different types of indexes we have. We can have a single field, which would say, I want to create an index on the ID field, and I would probably just leave it at that and let the sort order default to ascending because it's fine, it's a random string-ish. We can also have indexes on multiple fields. So we can have, say, name and address, or name and gender, or address and maybe name and email address would make more sense. So that if we know we're routinely going to query on multiple things at a time, say where a person's name is this and their email address is this, it would make sense to create an index that contains both of those fields. I've got a note here on multi-key array index types. I say we'll come back to this. For the purposes of this class, we will not come back to this. I would generally just avoid multi-key indexes. Geospatial indexes, this is actually a really cool feature of Mongo. I'm hoping we'll have time to at least get our hands on it a little bit, where you can have an index that is literally a 2D sphere geospatial index, which makes searching for distances between points or max distances between two people and things like that very easy. The syntax is a little bit convoluted, but it works pretty well. I already talked about the text index type, which you must use if you're going to use the text operator. And a hashed index type uses a hash of the value of a field as opposed to the actual value of the field. And so it can be potentially a bit faster and creates a more random distribution of values, but since you're hashing the value of the field, so you're not storing the value, just the hash, it only supports equality matches. You can't do greater than, less than, or things like that. So those are the types of indexes we can define. And for each of those types, we can define these options. Unique, again, if you're used to relational databases, a primary key field is typically a unique, well, it's a primary key, therefore it's a unique index, and it also is a required field. That is what a unique index option, or a unique of true in a Mongo index. That's effectively the same thing as a primary key. Partial is going to define an index that will only index documents that meet a specified filter expression. So you can say, I want to create this index, but only for, back to the age example, people in my database that are over the age of 30. For some reason, you want to index those, but not the ones that are younger than that. Sparse is pretty similar in that it will only index documents that have the specified field. So with unique, every document must have that field because it requires it to be there and be populated and be unique. With sparse, you can put an index on fields that exist in some documents and do not exist in others. And hidden indexes are more of a art than anything. They will not be used. They're more for evaluation and testing. So this is code on how to create an index. Let's go actually do it in Compass since it'll be a little bit more user-friendly for us. So I told you that we were going to create an index, a unique index on the ID field, because that's how we're going to routinely query this database, is say, give me the person with this ID. So I will say, I'm going to create an index and I'm going to name it, I'm just going to name it ID. And this is actually kind of nice. It gives us all the fields that currently exist and lets us choose as opposed to us typing it. We're going to do ascending. We're going to create a unique index, and seeing TTL reminds me that I forgot to tell you about TTL indexes. We'll go back to that here shortly. And this first option, build index in the background. For my purposes on this very small database, this does not matter. If you're ever building an index in a production commercial environment, you almost invariably want to build index in background, because if you don't, you lock this collection from being used in any way until your index is done building. So clearly, if you're adding this index to a production database that thousands of requests are coming in a second, and you say, go build me an index, but not in the background, every single one of those requests is going to fail until that index succeeds. So you're probably going to want to build your index in the background almost always. It is a bit slower, but you don't experience downtime from it. So I'm going to just say create a unique index. Now Compass shows us we have this new index, shows us the size it takes. So now let's query by ID. And again, this being a 1500 record database, we are not going to see some dramatic improvement between an index on the ID and a not having an index on the ID because it's just such a small amount of data. But if we run an explain plan on this, recall that previously it was doing a full collection scan and it had to look at 1,500 separate documents to find the one I wanted. Now that I have an index on the field I'm querying on, it had to look at one single document to know what I wanted. You know, I said it wouldn't be a dramatic change, but I think the last fetch, granted it was on the age field, but I think it was 300 milliseconds. So we went from 300 to 0. So I guess that is a notable difference. And you can see it indicates that it used an index on the right-hand side. And we no longer see a full collection scan down here. We see a index scan or an IX scan, and then a fetch when it took the result of that index scan and then went directly to that document in our collection and pulled it out for us. So I said that I skipped TTL indexes. I'm going to hit this really quick because this is, I really, really love TTL indexes, but it doesn't have a whole lot of bearing on this class. I want to make sure you know what they are though. TTL indexes, if you think about network packets, they have TTLs. So if you ping a server, there's a TTL that says after this amount of time, that packet is trashed. This is that same idea, but applied to documents in a database. So if you have data that you need to maintain temporarily, but not long-term, then you can set a TTL index on it and on a date field that is associated with the document. And when that TTL expires, Mongo will efficiently in the background at some time in the future, will just remove that data for you. Prime example of where I use this is I built a very large notification system where anything that happens in an ecosystem can generate notifications to users. And they're important in the short term, but nobody cares after 30 days if a particular job ran to completion a month ago. So all of those notifications went into a Mongo collection with a TTL index of, I believe I had 30 days. So instead of keeping all notifications for all eternity and constantly aggregating more and more data that's not super useful for anything, I just had it automatically delete documents that were over 30 days old. Nobody ever complained or asked to see anything later than that or older than that, so it worked out great. It's a great use for TTL indexes. You can call get indexes on the collection name, or you can use Compass, it'll show them to you. So we'll skip on past this. So the things that are important about making sure your indexes are useful. The index must exist on the field you're querying on. If you're doing a sort, it must be in the same order. And a compound index can be used for a simpler query if it's a prefix, meaning that the fields you're indexing on the compound index, those are the first things that you're querying. So if you're indexing on ID and name, and the first step of your query is to look for ID and name, then it can use your compound index. Indexes should always fit into RAM for efficiency. So either if you start exceeding your volatile memory, then you either need to clean up your index, re-index, or clean up your data or your query. Told you we'd skip multi-key indexes. Index names aren't important. Covered queries. What a covered query is, these are the absolute fastest way you can query Mongo. It's only a small subset where this is relevant, but if you can do it, it's blazingly fast. A covered query is where you have an index that is a compound index that covers all of the fields of what you're querying for. So I mentioned earlier, if we had an index on ID and name, if I query my collection just for the ID and name properties of my documents, it does not even have to look at my collection. It can get all of the information it needs from the index itself. They are crazy fast. In the interest of time, I'm going to skip past some of this stuff that's more just background. It's there on the GitHub for you to review if you'd like, but not as important as some of the others. Because what I'm really wanting to get to is aggregation. Let's see. All right, I know those last couple of slides, they're not super important to what you guys are looking for, so I just skipped them. Like I said, they're in the GitHub if you'd like to review them. But any questions over indexes? You want them, basically, but you want them to be correct. So aggregation in Mongo is the last topic that we absolutely have to cover because it is very, very important. It is effectively the same idea as a group by in SQL, also partitioning and windowing, that kind of thing. The way we do it in Mongo is very, very different. You will not recognize it. And I mentioned earlier that I was never really a fan of SQL, especially very complex SQL. Mongo aggregation makes a lot more sense to me. I think more functionally than I do declaratively. So it's a lot easier for me to write insanely complicated queries in Mongo aggregation than it is for me to do it in SQL. So what is the aggregation pipeline? Previously, we've just looked at db.collection.find, and there is also insert and create and delete. Right now, we're just querying. The aggregation pipeline is similar in that it's, if you were writing on a command line, db.collection.aggregate. And in the past, we had parentheses and then curly braces because we were declaring our query object. But since the aggregation pipeline is a list of stages that we're going to execute sequentially, instead of using curly braces, now we use the square brackets for an array, because we're going to pass it an array of objects that define each stage in our aggregation pipeline. Each stage is going to receive a list of input documents. At the very first stage is going to get effectively all of the documents in the collection. That stage's logic will then execute based on those documents. Let's say simple for now and say we're doing a filter, which is what we've been doing previously. Say, give me all people that are greater than the age 30. And then after it applies its logic, it will output whatever those resultant documents are to the next stage. Then we just loop. The next stage receives those documents. Say stage 2 receives documents that were output from stage 1. It applies its logic and then outputs the remaining documents to stage 3. Now we could be reducing down the number of documents, as in my example where I said, let's filter by age. The first stage filters anyone out who is under the age of 30. So we had 1,500 records input to stage 1. Say we had 700 output into stage 2, and then stage 2 works on those 700 documents. That is very common. It's not uncommon to be making more documents, to have 1,500 documents come in to our stage 1 and do some type of logic that explodes those into 3,000 documents that then stage 2 has to deal with. The easiest way to think about this is each stage is a small self-contained grouping statement, and you need to choose the appropriate one at the appropriate time for what you need to do. So let's talk about what those are. So these are our basic aggregation operators. There should be more on the next page. Good. And let me pop up an example so that you know what we're talking about. So I'm going to write an aggregation pipeline in this area, or actually an aggregation stage, and I'm going to use one that we're already accustomed to. I'm just going to do, I want all the documents in my database to come, or in my collection, to come into this aggregation stage. And then I want to filter it down so that only those with age greater than 30 make it to the next stage. So effectively the same as doing a find where age greater than or equal to 30. The operator is slightly different. It's called, well, the outer operator is called match. And effectively inside of match, we're just writing our filter query now. So I've said this stage is a match, and the query I would like you to apply to a match to filter this data down is age greater than or equal to 30. So this is what we're talking about when we're talking about aggregation operators, specifically this match in this case, and we're going to look at its brothers and sisters over here. We have add fields or set, they work the same way. That allows us to create new fields on the documents that we currently have. We have count, obviously returns a count. Geo near is geo-based querying, where we can create an ordered stream of documents based on the proximity to a geospatial point that we provide. Group is exactly, logically, it's exactly the same as a SQL group by, where we will provide the field or fields that we would like to group on, and then we have to apply some type of aggregate operator to all of the other fields if we're going to bring them through. Limit limits the number of documents. So if you're just doing a sample, you need to test this out on 10 documents. You could throw in an aggregation stage of a limit 10, and you'll only get 10 out of it no matter what. Lookup. Lookup is our quote unquote join operator. If you need to, I'm just going to use join. It's close enough. If you need to join one collection to another collection, then lookup is what does it. You should note it is only doing a left outer join. And it has to be in the same database, and it has to be in an unsharded collection. We haven't talked about sharding, but it's a efficiency thing when you get really big. I'm hoping to have an example of lookup for the end. I've got a simple one prepared. And match, again, is just our, here's some filter logic, apply it, and only pass through documents that meet those criteria. Project is very similar to our projection in our find queries, where we said show the include these fields and exclude these fields. Yeah, it's exactly the same. Skip tells it to skip the first X documents, the first number of documents. So you might look at skip and limit and think that that is a perfect way to implement pagination, because that's the terminology we typically use. Unless they've changed it, it's actually very misleading, because the skip was happening on the client side. So you still had to query all of the documents before you could do your limit and skip, and it was inefficient. Don't 100% trust me on that, because the last time I dealt with that was probably 2 years ago, so they may have changed it up by now. But that was an issue I've experienced in the past. Sort clearly sorts by whatever key you give it. And unwind is very special to Mongo. And I think I've seen some like PL SQL functions named explode that are kind of like this, where you take in one record or document and you turn it into a bunch of documents. That's what unwind does, specifically on an array. If you have one document with an array with 5 items in it, and you unwind that array, you're going to end up with 5 documents. So it basically takes the array and explodes it into new documents. And I do have an example of this.
Is that one example of what you were talking about? 1,500 records turns into 3,000, where you start to explode the
Exactly.
subgroupings. Yeah.
Actually, since we're on that, before we talk about accumulators, let me write a quick example of that, because this is going to be easy. So this is my aggregation stage. I've deleted the match because now I want to do an unwind. So I'll tell it I'm doing an unwind. Actually, I don't even need these braces. I was double checking my example. All I have to do is tell it the field I need. Terminology gets tricky here. On one hand, it needs to know the field that is an array that is going to unwind on, which I'll use hobbies. However, this is going to error when I execute it, if I can find the execution button. Or is it not executing it automatically because I'm getting it wrong? All right, so this is one thing I don't like about Compass is I just want to execute this. And I can't execute it here because the documents page only allows me to do simple finds. So I'm just going to pull a quick thing up. And if it doesn't load in about 10 seconds, I'm going to give up. Or I give up because it's totally off screen. Yeah, what's throwing me for a loop is that it's no longer executing this query. Anywho, I will demo that on the Mongo shell later, so I don't waste too much time for us. So accumulators are what we use inside of a group stage. So we already have to have a group stage defined before we can use these operators. Add to set is extremely helpful. It creates an array of unique values for each group. And the key there is unique values. There are other operators we can use to just say, give me all of the values in this group and accumulate them into a new array. Add to set specifically ensures that that remains unique. So you can kind of deduplicate values there, or you can deduplicate values there. We've also got our standard mathematical operators like average, first, last, max. Clearly, we're going to see min on the next page. Min. Push is the one that is similar to add to set in that it adds things to an array from the group, but it is not unique. So you can end up with duplicates. Sometimes you want all of the values, sometimes you don't. If you just want the unique values, then use add to set. If you don't care, push. And of course, mathematical sum, to sum of all numerical values. And merge objects, personally, I've never needed to use this. I've always been pulling out and manipulating specific things, but it tries to combine input documents into a single object and smash them all together into a single one. I guess I can see where that'd be useful. It's just never been a goal I've had. So one important thing that I was hoping to show you with that unwind example is that when we're working in the aggregation pipeline, if we are going to refer to the value of a field, just like similar to how we prefix our operators with a $, because that's how they're defined, if we need to use the value of a field, it does need to be in quotes, but it needs to be prefixed by a $. And that's where I was going over here. Is if I switch this back to an unwind, it may seem obvious that you should say unwind on this field, but since we need to use the value of this field, again, only for aggregation pipelines and only when we're referencing the values of specific properties, we need to enclose that in quotes and prefix it with a $sign inside of the quotes. So what this is saying is go find a field named hobbies, take the value out of that field, and now apply the unwind operator to it. And in the example on my page here, I was doing a grouping with a max of cost. So if we grouped 30 items, and we would then be creating a new property named max cost, and that property would now, it would receive the value of the document that had the highest number assigned to the cost field, or the highest value assigned to the cost field. Again, if you start working with very large data, the group stage has a limit of 100 megs of RAM by default, and the stage will return an error if the limit is exceeded. So you can work around that. You can enable disk use and swapping on your database, but clearly you're going to incur a performance hit if you start swapping. So for the most part, try not to do that. And that actually reminds me that one thing we haven't talked about is that Mongo documents, individual documents within a collection, as of right now, have a maximum size of 16 megabytes. And I know that seems low because we work in gigabytes and terabytes and even petabytes these days. I've actually never even really gotten close to exceeding that because it is compressed VSON. The only time we've hit it is because when we had a bug that was accidentally smashing thousands of documents into a single document and then trying to insert it, and it was 18 megabytes, exceeded 16. It has never really been a problem for me storing generic JSON metadata, but just know that it's out there. It's something to keep in mind. They do bump it up occasionally. It's been many years since they've increased it again. I think the original was 4 megs. So I wouldn't be surprised if they increase it again in the future, but as of right now, 16 megs per document is your limit.
Per document.
Per document. So
and you can have multiple documents in a large file,
right?
Operating system file.
Mm-hmm. Yeah, I know one of the collections that I worked with commonly at my old job was routinely in the hundreds of millions of documents, and most of them, there were a couple of big ones that may have been up around the 8 meg size, but that's still half of the limit that you were looking for. So the equivalent of, again, documents are effectively records in a table relational wise. So it'd be like having a 16 meg limit for a particular row in a table.
And that, does that include blobs?
It does.
Okay, so if there are images or whatever embedded in that JSON file,
right? And the general
idea
there is we have CDNs these days, so why would you store a blob when you could store it at the edge across the entire world, and it would be much, much faster? But it does come into play. The general argument is just don't do that.
Yeah.
So I'm going to drop this in VS Code so it's easier to read. If I can find it, here we go. So I'm not going to be able to make this one look terribly good because I am going to give you the command line or the command type access, where in Compass, it's effectively doing this part for us. I guess I'll switch this to people. So this is how we chain steps in our aggregation pipeline. Line 2 is our match. I will make this more representative. I'll say favorite color is red. So the first thing we're going to do is say get rid of anybody whose favorite color is not red. When we have those people remaining, we want to group them by the color they like. everybody's favorite color. That's going to get hairy, or it's going to get confusing. So I'm going to switch back to age. And we'll go back to our age greater than 30. And then I will, what do I want to do? I want to group them by, it's a good property to group by. Gender is easy. So we'll group them by gender. And then we want to do some type of accumulator. So what do we want to do? We want to find all the hobbies, but we want them to be unique. So I will create a new field called all the hobbies, and I will do an add to set that uses the value of hobbies. And this is actually going to play really nicely into our unwind discussion, I believe. So now, quick review of what we've done. We've said first stage in our pipeline, match only those people that have an age property that is greater than or equal to 30, discard every other document, then feed the remaining documents, those who are greater than 30, into the second stage in my pipeline, where I'm going to group by gender. And the way we do this is where in SQL we say group by field name or field names. We define that by assigning our grouping variable to our underscore ID field, which is only used for the purposes of this aggregation. It's not going to overwrite the one in your document. So this is effectively saying group by gender, and then we can do all the normal stuff we do in grouping in SQL, we can do here. I'm going to create a new variable called all the hobbies that has a unique array of all the hobbies that these people have. I'll do, say min age, and give me the minimum of the age field. I would probably also want to do max age. So I'll say, give me the max of the value of the age field. And just for fun, let's do an average age as well, since I'm on a mathematical kick. All right, I'm going to try to paste this back into actually, if I can import. So new pipeline from text, the little plus symbol, new pipeline for text will allow me to paste a JSON, kind of a JSON document that represents an aggregation query, so long as it's an array, and it will parse that out for us. So I'm going to say create new. Yes, I would like to. And all right, this is more what I was looking for. You can see that it has separated our aggregation pipeline into its individual components. We have our first component or our first stage, which was a match, and applying this logic. And now I understand why I wasn't able to get this to work. I was writing my unwind in here. I should have been choosing an unwind operator up here. Specific UI issues. So I do like how it does the aggregation pipelines as we'll continue to walk through this, but our first pipeline is going to give me, it's not going to pass documents through only if they have a property named age and it's greater than or equal to 30. And then this is the nice part, Compass gives us a sample over here of the documents that do pass this logic. Then we, all of these documents, and this is just, again, a sample of 20, all of the documents that output from that will then go into our group stage. You can see that I have an issue here because I've mistyped add to set. It is case sensitive and I have a lowercase s. Now that that is a syntactically correct, a valid operator, then it executes our group and gives us the documents out to the side. So you can see the ID field is whatever one of the values of gender was. And then we've got the minimum age, max age, and average age for everyone who identifies with that particular gender. Which we do have some null, minimum age of 30 and a max of 110, and so on. So that is a quick and dirty match, filter, group, generate new fields, and apply stuff to it. I have just realized that I did not show you what's in the all hobbies array. And that is a little bit on purpose because it's not going to be correct right now. In fact, it's oh, these are people with null. Let's check a couple of other ones. Yeah, you can see what I want all the hobbies to be is a list of strings that is a unique list of all the hobbies for all of these people. What I've actually gotten is an array of arrays. So basically I've taken the array from each person that's in this group and pushed it into a different array, which isn't very helpful for us. Which leads me directly into when we want to use unwind. I think for efficiency, for time efficiency, I'm going to put it before our group. So I'm using the UI to insert an unwind stage in between the existing match and group. And I'm going to find unwind in my list. It conveniently fills in some documentation for us so we know what we're doing. The path is going to be hobbies, specifically the value of hobbies. And for right now, I'm going to cut this out. Let's see if this makes it happy. All right. So fitting it on screen is going to be slightly difficult, but you should be able to at least get a feel for this. And I wonder if I still have room with 3T. So we'll be able to tell this based on the ID field that we know that we've taken one document and exploded it into multiple documents. So originally, Jeffy Founding with ID 4DDE had an array of hobbies. We're about to find out how many hobbies he had. When I unwound all of our documents based on the hobbies field, effectively, if that array had 3 properties in it, 3 items, that one document will become 3 documents. All of the data will be exactly the same, except for the field that was previously an array will become a static value of whatever associated item in the array is given to it. So he used to have a hobbies array that contained movies, running, and apparently that was it. He only had 2 hobbies. So now when I unwind these documents on hobby, what was he? Jeffy Founding becomes 2 different documents, or his single document becomes 2. And now instead of containing an array in the hobbies field, it contains the string of the value associated with one of his hobbies. So if we, out of curiosity, insert a count, here, this is going to break our downstream that doesn't seem right. All right, I'm doing something wrong with count. What I was hoping to do was look and see how many after we, oh, it's because I got a filter. What I did wrong is when I did the count here, I saw 1345 and thought, but we started with 1,500 documents. How am I down to 1,300 when I just unwound them? I forgot that I have a match up here. And so there's two things I could do here. I could insert another aggregation pipeline in the middle and get a count here. Or, and this is one of the things I do really like about Compass, these slider buttons here, I can just turn off this stage. And so now we know that since we're not doing any filter, the first thing we're doing is an unwind on hobbies and doing a count. And we can see that we're exploding 1,500 records into 1,791. It breaks our downstream stuff because of the count, but then I can turn count off and we're back to a functional unwinding group. And now you can see that our hobbies are an array of strings instead of an array of arrays. And you'll also notice that since I used add to set, these are unique values. You can see hiking only exists once in this group and so on. Took me a while, but I eventually got there. So I've got some examples here. I would also say that I have some examples in this commands and queries document. It's nothing special. There's a few helpful commands and a couple of operator examples. These are just for reference, and also some poorly formatted practices. Don, are we going to 12:30? Is that right?
Yeah, max.
Okay.
You doing okay?
Yeah, I was going to see if we could do a 5-minute break, and then I will start working on wrapping up.
Sure. Yeah, let's take a top of the hour.
That'd be perfect.
Top of the hour. Come back because my mind is reeling with the applications of a lot of this stuff. So y'all get your questions ready and we'll reconvene at 12 high noon.
Sounds great. Thank you. All right, so need to pause for questions first, and then we'll talk about the last section. Any questions?
I'm going to hold till the end.
Okay, that works too. In that case, we have 2.5 more things that I want to make sure we cover. One is geo indexes, because these can be very, very helpful for determining distance and I mean, it's all around distance, but finding the people who were closest to a certain area. Say we're wanting to do a marketing campaign for, off the top of my head, Home Depot. And so we want to find everyone who lives within a 20-kilometer radius of this particular Home Depot, and then send them a mailing that says, thanks for being part of our community. We're going to offer you 20% off or something like that. As part of that, we're going to get to that other half. I'm going to show you something cool that's good to know. So in order to do geo queries, we need a geo index. We currently do not have one because we've seen all the indexes that we created, and so far the only one that wasn't automatic was our unique key on ID. So first we need to create an index on our geo coordinates, which if you look at one of these, you can see we do have latitude and longitude fields. However, this is not in a format that Mongo can natively support. We can't tell it to do a geo index where latitude is stored in this field and longitude is stored in that other field. It just, limitations of the software, it can't do that. We need to put it in a format where we have something like a coordinates field that contains both the latitude and longitude in an array. So we need, since I know all of my data looks like this because that's how it was generated, I need to modify every document in my database, or in my collection at least, to create a new field, we'll call it coords or coordinates, that is an array, and it contains the value that already exists in latitude as one item and the value that already exists in longitude as the other item. Pretty common thing in SQL, right? It's a little bit more complicated in Mongo, I think. In fact, I don't think it's going to be possible for me to do it in the areas that Compass allows me to do, but we do have access down in the bottom left to the Mongo shell, and this is effectively the Mongo command line. So since Mongo Compass will allow you to update documents by looking at a single document, clicking the field and modifying it. I need to programmatically modify every document. Otherwise, I'll spend the next 4 hours manually modifying these documents and wasted all of our time. So what better to do something automatically than a quick script or query. I've already written this query because this is not something I do that often, so I made sure I had it saved. And there is a section about geoindexes and queries down here. So what we're going to do is steal this query, and I'm going to paste it in, and then we're going to talk about it real fast because it's quite a bit different from what we've seen previously. So reading this from left to right, we are doing our standard db.getCollection. We could have also just said db.people. The get collection thing is a old convention. It still works, and it's common to use in JavaScript. The IDE, which was Robo3T that I originally wrote this in, it defaults to this, and I probably just copied it from there. But effectively, we're saying on the collection named people, I want to do an update many. All of our inserts, updates, and deletes have a insert and an insert many, or an update and update many. If you use the singular one, it will at most modify a single document when we're talking about update. Same with delete. So that's a way where you don't run into that accidental situation where your query was overly permissive and you were doing a delete and you meant to delete one document and you deleted 25,000 because oops. So if you know you're only planning to modify or delete a single document, use the singular command of update or delete. Only when you're positive you need to do be modifying more than one, that's when you use update many or delete many. On our update statement, the first parameter that we pass it is our filter. So which documents are we wanting to apply this to? By supplying an empty brace or 2 empty curly braces, we're saying this applies to all documents because I'm not filtering in this in any way. And in this situation, which is rare, but it does happen, I am wanting to modify every document in my collection. And then this is the kind of new thing. I think this came out in version 4, which they're on 5 now. Don't fully trust me anytime I tell you when a certain feature was added because I don't pay super close attention to it until it bites me. But as of 4-ish, they added a new function to update many where we can actually provide an aggregation pipeline here. And so this is truly an aggregation pipeline, at least a subset of one, a single stage. And what it's saying is I'm going to invoke the set operator or the set aggregation operator. And I want to create a new field on every single document named chords. And that field should be an array that contains the value of the field named longitude on that document as one property, and the value of the field named latitude also on the same document. So effectively, we're going through every document and saying, I see you have a latitude and longitude. I'm going to put you together in an array and assign you to a new field. Another extremely important thing to note here is when I think latitude and longitude, I think latitude then longitude. For this to work with geoindices or indexes in Mongo, it has to be in order longitude, latitude. So if you reverse those and do them the way I say them and typically think of them, it will not work and you will get crazy errors until you realize that you have them reversed. So longitude should always be first and latitude should be second. So I'm going to execute this, which should update every document with a new field named chords. And let's minify this and check if that actually happened. And it did not, and I was worried that was going to be the case because it said modified 0. Ooh, and I think I know why, because I think it's defaulted me to the test database and I need to be in, what do I call this, ACDS? There we go, now I'm in the correct database. So let's try that again. And you also notice that it didn't error even though that collection didn't exist. So now that I'm in the correct database, let's try this again. Now we can see that it matched 1500 documents. So our filter, which was all documents, matched 1500, and we modified 1500 documents. So now if I refresh our view over here, we should actually have a property named chords on every single document that also matches the properties of latitude and longitude. And you can see we did get that in the correct order, where chords index 0 is -78 and chords index 1 is a latitude of 42. So now that we have this field, this chords array that we can apply a geo index to, I'm actually just going to do it via the command line as well, because I already have this command written, and so that I don't have to fiddle with the UI. So db.people.createIndex, the field we're creating it on is named chords, and the type of the index is 2D sphere, which of course is a geo index. And since we're already on the command line, let's do a db.people.get indexes and ensure that it did create our index. And we can see it right here and all the information about it as well as the other ones. So now we actually have a geo index that we can query against for geotype queries. And I'm actually going to move this window off to the side so I can see it and copy paste easier without having to continually switch back and forth. So one of the, since these are not simple to write on the fly, I've prepped a couple of different queries for us to play with. And one of those is I want to find everyone in our database who lives in a geographical area. And the way I'm going to do that is I could potentially, since I'm going to basically say, give me everyone in Arkansas, I could just query where the address state code is AR, and that's probably right. But for our example, I'm going to query pretty much all of Arkansas as a geopolygon. But of course, if we just wanted to find people who live in this geographical area, we can do that as well. I'm going to use the entire state as an example. So what I would do is go grab all the geo coordinates that I want to build a polygon. So I'm going to build, to keep it simple, I'm going to build a rectangle-ish where I'm going to get GPS coordinates from the top left of the state, or northwest, the northeast, the southeast, and the southwest. And then I'm going to ask Mongo to build a polygon between those points and tell me, of all the people in my collection, who resides based on their GPS coordinates in this geographical area. So looking for my window again that I've lost, here we go. And again, copy paste because this is a lot to type out. And I will have to correct a little bit of this and make it more readable. So I need to take out the db.people.find because Compass is already doing this for us. And then do a little bit of formatting on this. So this is still pretty nasty, but again, this exact command is in, this exact query is in the commands and queries markdown document in the GitHub, so you can also just directly copy it from there. What I've written here is effectively just another match or equals query. So where I'm saying chords must match these criteria. Only this time, instead of using equals, I've said geo within, using the geo within operator, and then I've told it I'm going to give you a polygon, and I need you to look at the chords field, which contains a longitude, latitude, build a geographical polygon based on this input I'm giving you, which is effectively Arkansas, and then find everyone who resides within that generated polygon. So if I hit find and hope I copy pasted correctly, you can see I get 4 documents. So apparently only 4 people live in this polygon. So let's take a quick peek and see if their address information lines up. I believe from my initial testing it did, and I was actually a little bit surprised because this is randomly generated data, where it would randomly gen latitude and longitude and randomly gen Arkansas. So if they coordinated those two to make them mesh together, I'll be impressed.
Oh, so you're saying the randomized data? Oh, but it got the Latin long of Little Rock at least
Yeah, I
in the
think
random data. Okay, yeah.
Yeah, I'm impressed. I was not expecting that when I put this together, so I was very happy to see that.
Wait a minute, they don't live in Arkansas. It's random data.
So yeah, apparently I used makaroo.com, and the actual schema I used to generate this is also in that data directory. I think it's called ACDS initial schema or something like that. If you want to build the same data set, you can either download it from GitHub or grab that schema, go to makaroo.com, upload the schema, and generate the same data and tweak it any way you want.
Okay, so say that again. The randomized pseudo data that we're looking at here with address and hobbies and whatnot is not ACDS dash. I had your GitHub up for a minute there, and
So
it's that top one.
yes, this is the schema. You can take this schema file and then go to Makaroo, and I think that you have to have an account to upload a schema, but it's free and they haven't spammed me, so you can upload the schema and it will be exactly the same as what we've generated.
But the generated data that you're dealing with is the ACDS.
Yes. Yeah.
Dash data dash one.
Yes, those two are the files that I imported into Mongo.
Yeah.
And the reason there's 2 of them is Makaroo has a limit to the number the free tier can download, and I wanted at least 1,500, so I had to generate 2. This combined ACDS data with coordinates is that the work we just did, where we combined the latitude and longitude into a chords array that we can then build a geo index off of. This is that same, all of the same data, but with that data already included. So I effectively generated it and then exported it again. And hobbies is we may or may not get to, we'll see. I was going to show you how to do a lookup, but based on time, again, the Mongo documentation on lookups is fantastic. So if you followed along with even half of what we've done, you won't have any problems with it. So our geo index with our geo within operator has worked just fine, and it's found us 4 people in Arkansas. For fun, we might want to say, what if we just searched for address.state as Arkansas? Are there only 4 people in the state? Or are there people who maybe lived on the edges that our polygon cut off? So out of curiosity, let's find out. And no, there are actually only 4 people in our database from Arkansas. So our geo query with our polygon actually caught every single one of them. Now I want to pull another query out of here. And I'll actually keep it on the screen so you can see exactly where I'm looking. Going to geo index queries. And the specific one I want to look at before we move to Atlas is find people that are in a circle around Little Rock with a certain amount of units. I believe that this one uses, oh, my memory's failing me, radians? Oh no, that wouldn't be 2.
I think it's down one line. Looks like it says with radian units, right?
Ah, here we go. Yes, this is the radians one. This is what I'm looking for. There is a, what this is effectively doing is it's calculating radians based on 100 miles divided by 39632, which I think is the diameter of the Earth, and that will give us radians. So let's use this one.
Yeah, that sounds right. Circumference is 25,000 miles, give or take, 24,000.
All right, so we've pasted this in and we haven't changed much. We've chosen center sphere as our operator instead of polygon. and said that I want you to choose this point in space, this GPS coordinate, and then in radians calculate every one of my document store that is within 100 miles of that translated into radians, I think. I do see I've got an error. I copied an extra parentheses. All right, and now we actually only get 3 people. I believe this coordinate is Little Rock. I think I chose the zoo if I'm remembering correctly.
Mm.
And we can see we've got somebody in Little Rock, also Little Rock, of course, and Little Rock. So there is one person who is in Arkansas, but is not within 100 miles of the zoo. So you can take that and extrapolate it into all kinds of other geoqueries. Any quick questions on that before I give you a peek at Atlas? Because that is a great reference to have. So again, I prefer, especially development testing, to do everything on my machine. So I know if there's a problem, it's my fault. I can fix it myself. However, MongoDB does provide a cloud service called Atlas that is free to use, and even better, and this is the big selling point I tell people, you do not even have to give them a credit card, so you know it's free. Unlike AWS, where they have a free tier, but you have to give them a credit card, and if you screw up and leave an EC2 instance running, then you come up with a large bill that you weren't expecting. We're going to see how fast this goes. I've realized I've just used the wrong account to log in, but hopefully I can get through the intro within 30 seconds. If not, I'll switch accounts. All right, so this is where you land. There is also a serverless option, which is pretty nice. Most people go with dedicated. Us, we're testing. We want a free shared cluster. It can deploy in all of the major clouds, AWS, GCP, and Azure. Of course, you can choose the region within that. I'm mostly just going with the defaults. If you're familiar with AWS and GCP, then this is all old hat to you. The cluster tier is going to be chosen for us because we're using the free version, and we will give it a name. We'll call it ACDS. Yeah, let's leave it ACDS. And say create cluster. You can do your authentication multiple ways. I am just going to generate a secure password, and if we have time to actually integrate with something, we will, and it won't matter if you see it because I can set this to expire in 5 minutes. But I will create my user. And now, of course, I need a database. It is working on doing that for me. And it is actually quite fast. I think, well, it says here 1 to 3 minutes for the free tier, and that's been accurate in my experience. So while we wait on that, let's look at a couple of other setup things we need to do. Just because it starts up a database for us, a cloud database, that doesn't mean that we can actually access it and use it. We need a user account because we need to be able to authenticate with that service and prove we are who we say we are. I did just set up a test username and password, but by default, it's also limited network-wise to what can access this. And by limited, I mean nothing can. You have to go and explicitly add a IP address to the access list in order for your computer to talk to your new cluster. I'm going to choose, there's a button for add my IP address. Keep in mind that's probably dynamic. It may change by day. So if you come back tomorrow and you can't log in, it's probably because your IP changed. If you want to get, I don't recommend it, but if you're going to be doing a lot of changing around for the short term, you can whitelist the entire internet. Definitely make sure you have a username and password set and don't leave it that way for long. But if you need to, then that isn't a possibility. And it did create my username test, and I copied my password off to the side. So let's see if we're up yet. Almost there. One thing that I've found pretty nice about the correlations between Mongo Atlas and Compass is the UIs are really close to the same, the web UI versus the downloaded Compass UI. But it doesn't really matter because we can also connect Compass directly to our cloud database, assuming that A, we've set up a username and password, which we have, and B, we've allowed network access via the network access security tab. So it appears that our cluster is up and running. If we hit connect, I believe it will give me the different ways I can connect. Of course, I want to use Mongo Compass, and I already have it. So really all I need to do is copy this connection string, pop over to Compass and say new connection, which opened on my other monitor, and drop this connection string in here. You can see it is asking for a password. I am not going to worry about censoring this since I'm going to tear this cluster down immediately after. And so now I've got my username, my password, and the URL that they provided me, and it even defaulted to a database name test, and we'll hit connect. And you can see a little bit more information with Atlas than we saw when we ran locally. You can see that I have 3 different servers, 3 different shards. It tells us that they are in a replica set, so they are all replicating back and forth. I have no databases, but I can create one. I'll just create a database name test and a collection name test. And of course, we can do anything that we did locally, we can do it here. And again, this is 100% in the cloud, available across the internet, available to the entire internet if you give it permission, both with username and password and the network access. So if you need a place to play, perfect place for it. Again, note, I never gave them a credit card, so the worst they can do is shut down my cluster. No big deal. That was the last big thing that I wanted to cover. So we only have 5 minutes left, but at this point, I think I would shift back to any other questions or anything else I can help with.
All right, guys, questions, comments from the group? Don't be shy.
I don't know the answer. I can definitely make something up.
Okay, well, I was hoping to, this was a great demo, Cameron. Thank you so much. Into the guts of the query language and the syntax of JSON and how you can start pulling individual stuff out and get it answers. You know, what's the largest of this or the smallest of that, or you know, actual like English language questions and how to convert those into the query language. But I wanted to pull back just for a second, a little bit more to the kind of the strategic level and talk about what, you know, where JSON data is out there, what's generating it, why something like MongoDB is useful. But then remember, these are analysts, these aren't application developers. So they're faced now with JSON data. Now what? You know what I mean? Now how does JSON data in a MongoDB get kind of converted out to something that can be, you know, charted, used as a report kind of thing? That was about 19 questions all in one. You got 3 minutes left. Go.
Yeah, I can do it. Yeah, so JSON data is literally everywhere. It's always traveling across the internet. It's provided as data files in many situations, and this has happened to me in the past several times. Someone has said, here's a JSON file that I need to analyze. Well, I shove it into Mongo and then I start querying it. If you need to get it in other formats, depends on where you're going with it. There are a lot of reporting tools these days that do read JSON. Kibana, Grafana, Datadog. There's a really fancy one, Tableau. That's the one I'm looking for. They can all read JSON data, and I'm sure there are a bunch more. So it all depends on where you need to go, but also since JSON has been around for so long and it's so standardized, it's very common to either, assuming the system that you're trying to use for reporting or analysis can't read JSON natively, it's very common for them to provide a tool that says, give me your JSON and I will transform it into the format that we require, and then you can work with it. I see that all the time. If not, if that actual provider doesn't give you that service, I wouldn't be surprised if there's somebody on the internet who has already done it or who could do it rather easily. The main problem you run into there is if you're trying to get it into a proprietary format that there are no standards for. Luckily, we've mostly moved away from that, but it does still happen. So that is something you'll have to watch out for.
Yes, most folks are used to dealing with tabular data, which I'm sure there are ways to unwind and turn JSON files into the appropriate tabular data. I guess that's really the trick, isn't it? Learning how to work with it. Like I've pulled in Google Maps reviews into Python, and you get this 7-layer dictionary of dictionaries of dictionaries, list of lists of lists kind of thing. And it's parsing through all of that and knowing what you're looking at. That's, I guess, the challenge, because it's kind of unfamiliar when you're just used to getting a flat file.
Mhm. I will say, again, I haven't really been on the relational side of things for almost 7 years now, but right before I transitioned over, Oracle had something, I think it was somewhat new, where you could effectively define a JSON type field in a relational database and just say, here's my JSON, and then you could query against it at a very basic level. You could at least say, I know this column contains JSON, treat it as such, and go pick out this JSON field for me. I would hope and assume that they've improved it since then, but it was a very small project I looked at very briefly, but that is potentially another option.
Yeah, I don't know. We'll add that to the list of things I don't know. But all right, everybody got about a good 10 Mississippi to ask questions. So I wanted to thank you again, Cameron. Your expertise and familiarity is readily apparent. Very well prepared lesson plan. Really appreciate it. For the class, we may deal with a little bit of JSON here and there with like Power BI or Python, but I just wanted you guys to see that there's more out there than good old SQL and flat files.
Yes,
Okay.
sir. Thanks for having me. I appreciate it.
We will reconvene at 10:30, guys. 10:30 on Saturday. Give you a chance to put a couple more hours into your Python data analysis projects. I'll send out an email to back that up. Any questions on that Python project while you got me? All right, guys. See everybody Thursday morning at 10:30.